Hello and welcome to this channel where mathematics is made simple with clear steps and exam-focused explanations. If you're preparing for KCSE or CBE mathematics examinations, then you are in the right place. In this complete more than 2 hours lesson, we are going to solve all the 24 questions of KCSE Mathematics Paper 1 2025, step by step from question 1 to question 24. Exactly the way the examiner expects. This is not rushed, this is not guesswork. Every solution is clearly explained with proper mathematical reasoning, correct working, and accurate final answers. As you go through the paper, I'll be trying to break down each question into simple steps. I'll be showing you the common mistakes students usually make, and I'll be trying to the best of my ability to explain all the methods that I'm going to use in the various questions in this paper. Whether you are a Form 4 candidate, a teacher who is revising with the students, or maybe a KCSE graduate who is just checking your answers, then this video is designed to help you understand, correct, and improve your performance in mathematics. Now, it is very important that as you continue with the video, you can pause the video at each question, try it on your own first, then continue to watch the solution. That is the fastest way to improve your confidence and your accuracy. I'll be leaving the link to download the question paper in case you don't have the question paper in the description. You can check it, and that will go a great step in helping you as you follow through the video. If you find this video helpful, consider to like the video to support the channel, subscribe to the channel, and share this video with a friend who needs help in mathematics. Now, without wasting any more time, let's begin with question 1 of KCSE Mathematics Paper 1. Question 1, without using mathematical tables or calculator, evaluate. So in this question, you're supposed to ensure that you show all the workings and strictly adhere to the instructions given. Don't use mathematical tables or calculator. So any evidence in any of your steps that you have used the calculator can lead to loss of part of the marks or maybe all the marks. So you need to be very careful when you proceed by ensuring that you show all the workings. Now look at whatever you're given there. You have two operations inside the root sign. So you have division and you have subtraction. So according to the law of BODMAS, what are you supposed to start with? You're supposed to start with division, and then subtraction should come at the end. So which part are you supposed to divide? So you have a third divided by 1.5. You can write that one as an improper fraction, and that will give 3/2. So simplify these. This will be a third times 2/3, and this gives 2 divided by 9. So that is what you get. Now you have in the next step, now you should have 11 divided by 12, subtract what you got there, that is 2 divided by 9. So now you can go to subtraction. So take 11. So take 11 divided by 12, subtract 2/9. So how do you subtract these? Get the LCM of 12 and 9, which is 36. 36 divided by 12, that is 3 times 11, that is 33. Subtract 36 divided by 9, that is 4 times 2, that is 8. And then you have 25 divided by 36. So now you have, in the root sign, you have simplified everything. So you have divided. So for that part, you got 2/9, then 11/12, subtract 2/9, you have 25/36. So the next step now is to get the square root. So how do you get the square root of 25/36 without using the calculator? Now this is how you're supposed to do it. Express 25 and 36 as a product of its prime factors. So 25 will be 5 multiplied by 5. And then 36 will be 6 multiplied by 6. Then you get the square root. Now remember, when you're getting the square root of a number, you look for a number that you multiply by itself to give you that number. So if you want to get the square root of 25, which number do you multiply by itself? Already when you express it in factor form, you can see that the square root of 25 is 5, then the square root of 36 is 6. Now when you're getting the square root of a number, remember, these can either be positive or it can be negative. So don't forget to write that. That is very important. So you can either get a positive value or a negative value when you get the square root. So that is how you're supposed to solve that question. We go to question 2. Baraka earns 210 per hour working at a supermarket. The employer changed the amount earned per hour in the ratio 8:7. Determine the amount that Baraka would earn in 10.5 hours at the new rate. So when you look at this ratio, you're supposed to make sure you understand what happens to this amount. So the amount that he was earning was 210, and then the employer changed that amount in the ratio 8:7. So is it an increase? Does this ratio represent an increase or a decrease? This is definitely an increase. Why is it an increase? Because when you look at the ratio 8 divided by 7, this one you're going to write it as 8 divided by 7. So this one is definitely going to increase. When you take 8 over 7 and then you multiply by 210, it is going to increase that amount. If it was a decrease, for instance, maybe it would have been 7 over 8. So when you take 7 divided by 8, which maybe the ratio could have been 7:8. If, for example, it was a decrease, it could have been 7:8, where you find the denominator is bigger than the numerator. So therefore, the new rate, now that we have identified that this ratio is going to increase, so it will be 8 divided by 7, that is the ratio, multiplied by 210. And this will give 30 times 3, this will give 240. So the amount increased from 210 to 240. And this one is per hour. Per hour. So if in 1 hour, the amount paid is 240, what about 10.5 hours? How much is going to be paid? So you simply need to multiply these to get the answer. So we'll take 10.5, which is 21, divided by 2, multiplied by 240. By 2 and by 2, 120. And when you multiply these, 21 times 120, this gives 2520. 2520 as the solution. Go to question 3. So for x in the equation, this is a question on indices. Now when you look at this equation, the first thing you're supposed to check is whether it is possible to express all these values to the same base. So when I look at 4, 8, and 32, it is possible to express this one in power form to the base of 2. Let's start with 4 to power 3x. 4 is 2 squared, that is 4, and then you have 3x there. And then we have 8 can be expressed in power form, the base of 2, to be 2 cubed. And then 1 divided by 32 can also be expressed in power form to the base of 2, and that 2 will be 2 to power 5. And then you have that, which is a 2 raised to power 2x minus 3. So we can simplify these. So 2, this will be 2 times 3x, that will be 6x times 2 cubed is equals to. Now we need to be able to simplify this, the inverse. This is the inverse. So 1 divided by 2 raised to power 5 can be written as 2 raised to power negative 5. Remember this, that 1 over n can be written as n raised to power negative 1. That is the concept, the inverse. So therefore 1 divided by 2 raised to power 5 can be written as 2 raised to the power negative 5. And then don't forget you have 2x minus 3. So now I can simplify this part, the law of indices of multiplication. So 2 to the power 6x times 2 to the power 3. So that one we are going to add the powers. 6x plus 3 is equals to, so this is a 2, and then negative 5 times 2, that will give negative 10x, and then this is negative 5 times 3, this will be negative 5 plus 15, like that. So now, because you have the basis being the same from both ends, you can simply equate the powers. So I can simply equate the powers, and this will give 6x plus 3 is equals to negative 10x plus 15. So like terms together, so you have 6x plus 10x is equals to 15, subtract 3. So this will give 16x is equals to 12. So x will therefore be 12 divided by 16. And you can simplify these by 4, 3 by 4, 4. So this will give 3/4. 3/4 as the solution. Simple. Question 4. Solve this inequality that is given here, giving the answer as a combined inequality. So how do you solve this inequality? Now the first thing you're going to do is to extract two inequalities from this combined inequality. So already the inequality that you're given is combined, so you need to extract two inequalities, and these are going to extract them. So from the left hand side, I will take that one, that will be the first one, that is the first inequality that I'll have. So negative 1 less than or equal to 5 subtract 2x, everything divided by 3. So we first solve this before we go to the other inequality. So in solving it, we will simply solve for x, and you can see where x is. X is on the right hand side, so I'll need to eliminate everything from the right hand side in order to remain with x. So the first thing I will do is multiplying both sides of this inequality by 3. That is the first thing. So this one I'll get negative 3 less than or equal to, so this one you get 5 subtract 2x. Then from there I can take several ways of doing this. So I can take this one to the left hand side, negative 2x to the left hand side, and then this one negative 3 I can take it to the right hand side, just in order to bring x to be easier doing it that way. Bring x to the left hand side, so I'll have 2x less than or equal to 5 plus 3, and this will give 2x is less than or equal to 8. So once you've done that, divide both sides by 2 and you get x is less than or equal to 4. That is the solution for the first inequality. We extract the other inequality. So the other inequality, I will extract it this, that is how I'll get it. So that will be the second one. So the second one will be 5 subtract 2x divided by 3 less than 2x subtract 1. Again, you solve for x, so I will begin by eliminating these 3 by multiplying both sides by 3. Multiply both sides by 3, and this gives, so this one will divide out, so we'll have 5 subtract 2x less than, this will give 6x subtract 3. Everything here, you open these brackets, multiplying everything by 3. Like terms together again, so I'll take x the x's to the left hand side, the constant to the right hand side. So this side I have 2x, negative 2x, then subtracting 6x from both sides, I'll get negative 6x less than, then this will be negative 3, subtracting 5 from both sides, you get this minus 5. So negative 2x subtract 6x, that will give negative 8x less than, this will be negative 3 subtract negative 5, negative 8. So divide both sides by negative 8, and when you do so, the sign changes. In inequalities, the moment you multiply or divide both sides of the inequality by negative, the inequality sign changes to the opposite. Like this one is less than, so it will change to greater than. So this will be negative, this will be positive 1. Negative 8 divided by negative 8. So these are the two solutions. These are the two solutions. So you need now to combine them. Combine the two. Now combining the two, you have x at the center, then less than or equal to 4, and then x is greater than 1, so that means 1 is less than x. So you can just put it here, 1 is less than x, and by doing so you have the combined inequality there. We go to question 5. Question 5 is here. The following figure represents a rectangular farm, PQRS, of length 210 meters and width 120 meters, drawn on a grid of 1 centimeter squares. The dotted area inside the farm represents a flooded section. So the diagram is there. Estimate in meters squared the area of the farm that is not flooded. The area that is not flooded. Not flooded. So the one that is dotted is the one that is flooded. So the one that is required is the one that is not dotted. And how do you get that? You get the area of the rectangle PQRS, then subtract the area of the dotted. By doing so, you'll be left with the area that is not flooded. So this is how we're going to do it. The first thing we'll do, we need to get the scale, because you can see the length is 210 meters, and then this is represented. It is drawn on a grid of 1 centimeter squares. 1 centimeter squared. So you can see we have 1 centimeter squares, and then we have the whole length given in meters. So we need to know the scale that was used. That means we need to get what does 1 centimeter represent in terms of meters. 1 centimeter represents how many meters? How do you do that? You just need to use either the length or the width, just one of them. For example, if you consider so you're getting the scale. If I consider the length is 210 meters, and along that 210 meters, there are how many centimeter squares? 1, 2, 3, 4, 5, 6, 7. There are 7 centimeters squares. There are 7 squares that measures 1 centimeters each. So by taking 210 meters, I divide by the number of squares that are along that length. I'll be able to know what does 1 centimeter represent. It is 200 divided by 7, which will give 30 meters. In simple terms, we can say that 7 centimeters represents 210 meters. So what about 1 centimeter? That is why we are taking 210 divided by 7. You can also use the width, which is 120 meters, and still get the same answer. Now, because we are interested with the area, we therefore need to convert this. So if 1 centimeter represents 30 meters, so what about 1 centimeter square? 1 centimeter square is 1 centimeter times 1 centimeter. This will represent 30 meters by 30 meters, which will be 1 centimeter squared, would therefore represent 900 meters squared. Not this, we are going to use this. Now, to get the area that is not flooded, we first need to get the area that is flooded. the area that is flooded, and that is an irregular shape. So we need to get the area of that irregular shape. And how do we do that? We need to get the number of full squares. Full squares. How many full squares are here? I can only see one. Only this one is only one. And then half squares. Half squares, can count them from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12. Now to get the area, and this area will be in centimeters squared, I will need to get this is 1 plus 12. The half squares, you divide them by 2, and these will give 1 plus 6. These will give 7 centimeters squared. 7 centimeters squared. Why are we getting 7 centimeters squared? Because we're assuming all these squares will be 7, and the area of 1 centimeter or 1 square is 1 centimeter squared. So there are 7. This is just an approximation. They are around full squares. The full squares will be around 7. And bearing in mind that 1 square has an area of 1 centimeter squared, so 7 of them will be 7 centimeters squared. So that is the area that is flooded. So we can convert that. So if 1 centimeter squared is equals to 900 meters squared, what about 7 centimeters squared? So this will be 7 times 900, which will give 6,300 meters squared. So that is what you get, 6,300 meters squared. Then we need now to get the area. Now to get the area that is not flooded, the area not flooded, we said you're going to get the area of the rectangle PQRS, which is 210 times 120, 210 times 120 meters, and then we subtract the area that is flooded, which is 6,300 meters squared. So this gives 210 multiplied by 120, that gives 25,200 meters squared. Then subtract 63 meters squared, and this gives 18,900 meters squared. So that is how you're supposed to solve that question. We go to the next question. The next question is question number 6. Question number 6. So question number 6 is here. A relief organization donated 240 kg of maize and 150 kg of beans to the needy families. Each family received exactly the same quantity by mass of either maize or beans. No family received both. Determine the least possible number of needy families. The least possible. You need to get the question. The least possible number of needy families. Now, the amount of food to be donated in terms of maize and beans, we have 240 kg of maize and 150 kg of beans, and each family received exactly the same quantity by mass of either maize or beans. So the first thing that we need to do is to get the maximum quantity of either beans or maize to be received by each family. The maximum quantity of beans and maize, that is in terms of kilograms, to be received by each family. And how do we get that? We will need to get the highest common factor, or the GCD of 240 and 150 kilograms. So we need to get that, the highest common factor, or the GCD, of 240 and 150 kilograms. So that will give us the maximum or the greatest number of kgs of either maize or beans to be received by each family. That is what you need first to get. Then the moment we get that, we will be able now to divide by the total number of maize and beans combined, that is in kg. We divide and then we get the least number of families. So we get the GCD. So 240, you can use the factor method. 240, we express this one as in factor form. So 240, you have 2, this is 120, divided by 2, this will be 60, by 2, this will be 30, by 2, this will be 15, by 3, 5, then by 5, 1. And then 150, can express that one in power form. So by 2, 75, by 3, 25, then by 5, 5, then by 5, 1. So now we have for 240, let me write it here. For 240 in factor form, we have this is 2, 1, 2, 3, 4. 2 to the power 4, multiply by 3, multiply by 5. Then 150, the factors are 2 times 3 times 5 squared, like that. So now those are the factors. Now how do we get the GCD, the greatest common divisor or the highest common factor, using the factor method? So we consider the common factors. We look at 2 to the power 4 and 2. The common factor there is 2. And then we have 3. This is 3 and this is 3. So 3 to the power 1 is common. And then 5 and 5 squared, because you consider the common factor there is 5. So these are how we get the greatest common divisor. You can use the other method, still it works. This will be 2 times, this is 60, this will be 30. So that means the greatest quantity, or the highest or the maximum quantity that each family can receive in terms of kg is 30 kg. Now, having known that one family can receive a maximum of 30 kilograms, so what about 240 plus, so 240, so I'll add it here, so 240 plus 150. How many families are going to receive these? So the least number of needy families. So these will be 300 and 390. So these will be 390 kg. So we simply, if one family can receive a maximum of 30 kg, so what about 390 kg? That is the one that is to be donated. How many families will receive this? So we simply divide this one by 30, and this will give 13 families. 13 families. So that is how you're supposed to solve that. Question 7. Simplify the expression that is given here. So we will begin by simplifying the numerator. We get the solution and then we go to the denominator. Now let's go to the numerator. The numerator is x squared subtract 4y squared. How do you simplify this? You simplify it by factorizing. And of course, when you look at this expression, you notice that this expression is a difference of 2 squares. How do you know that? Simply because when you look at x squared, that is a square of x. It is a square of x. Then when you look at 4y squared, that is a square of 2y. So that is why we call this difference of 2 squares. You are subtracting the 2 squares. How do you factorize these? Now to factorize these, recall that given an expression like a squared minus b squared. To factorize these, you take a plus b multiplied by a minus b. That is how factorize that. So for this particular one, x squared minus 4y squared, we shall factorize it like this to be x plus 2y, then multiply by x minus 2y. So we're done with that. That is the numerator. Let's go to the denominator. So for the denominator, how do we simplify these? X squared plus 4xy plus 4y squared. So for this one, you have to factorize it by looking for two numbers by just simple factorization using the factors method. So look for two numbers whose product is the coefficient of x squared is 1, the coefficient of y squared is 4. So look for two numbers whose product is 4, and the numbers should also give the sum as the coefficient of xy, which is 4. So which are these two numbers? Now the numbers are 2 and 2. The numbers are 2 and 2. 2 and 2. So which then from there, how do you proceed? After getting the factors, how do you proceed? Very easy. This will give x squared plus 4xy. This is what you write using the factors. 4xy using the 2 and 2, the factors. So this will be 2xy plus 2xy, then plus 4y squared. So factorize between x squared and 2xy. What is common? X is common. So you are left with x plus 2y. Then between 2xy and 4y squared, what is common? Plus 2y is common. So you'll be left with x plus 2y as well. So this one gives x plus 2y multiplied by x plus 2y. So that is the solution for the denominator. Now let's get the solution, the final solution, simplified one. What we got in the numerator, x plus 2y multiplied by x minus 2y. Then what we got in the denominator is x plus 2y, x plus 2y. So when you look at the two, numerator and the denominator, there's something that is going to simplify. X plus 2y will simplify with the x plus 2y, and then you get the solution as x minus 2y divided by x plus 2y as the solution. Question 8. The area of a sector of a circle is 550 centimeters squared. The sector is curved to form an open cone of radius 7 centimeters. Calculate the height of the cone. Calculate the height of the cone. So what is going to help us to get the height of the cone? There's a statement here that the area of the sector is given as 550. Then that sector is curved to form an open cone of the radius 7 centimeters. So one thing that we get here is that the area of that sector, the area of the sector of a circle, will be equivalent to the curved surface area of the cone. Why? Because this sector is the one that is curved to form an open cone. So that means if I take the curved surface area of that cone, it will be equivalent to the sector where it came from. It was formed from the sector of the circle, and the area was 550. And that is why the area of the sector, which is 550, should be equivalent to the curved surface area of the cone. How do we get the curved surface area of the cone? By using this formula, pi r L, where r is the radius of the cone, and then L is the curved, is the slanting length, the slanting length. So pi r radius is 7 times L. So you can get L from this equation. So by 7,1 by 7,1, so 550 will therefore be given by 22L, and therefore L will be given by 550 divided by 22, and this will give, when you divide these, you get 25 centimeters. So that is the slant height of the cone. Now we can draw the cone. If I sketch the cone here, if I sketch it, you'll be able to now see how you're going to get the height of the cone. So that is the cone, and it is an open one. So if you want to get the height of the cone, so this is 90 degrees. So the height of the cone is there. So the slant height, this is L, which you got as 25, and then the radius is 7. So you can see that we have, from this triangle here, we can manage to get the height by using Pythagoras theorem. So we have, this is 7, this is 25, and that is the height. So the height of the cone will therefore be, using Pythagoras theorem, 25 squared subtract 7 squared, get the square root of that, and this will give 625 subtract 49, you get 576, get the square root of that, and this will give 24 centimeters as the height of the cone. Question 9. A clock which loses 18 seconds every hour was set to read the correct time at 8 a.m. on Monday. Determine the time in 12-hour system the clock will read on the following Saturday at 11:20 a.m. So that is a question. So the clock loses 18 seconds every hour. And now we need to get the total number of hours from Monday 8 a.m. to Saturday 11:20 a.m. The moment we get the total number of hours, then, and we know that in 1 hour it loses 18 seconds, we'll be able to calculate how many seconds it will have lost for all the number of hours that you're going to identify. So from Monday 8 a.m. to Tuesday 8 a.m., that is a total of 24 hours. Then from Tuesday 8 a.m. to Wednesday 8 a.m., that is another 24 hours. From Wednesday 8 a.m. to Thursday 8 a.m., that is another 24 hours. Then from Thursday 8 a.m. to Friday 8 a.m., that is another 24 hours. Then from Friday 8 a.m. to Saturday 8 a.m., that is another 24 hours. Then from Saturday 8 a.m. to Saturday 11:20 a.m., that will be, we can get that time difference. So we have 11:20 subtract 8 a.m. 08 a.m. So this will give 3:20. So that is 3 hours and 20 minutes, which is equivalent to 20 minutes is the same as 20 divided by 60. Convert that to hours, that will be a third. So that is 3 1/3 hours. So now we have the total number of hours. So all these hours, they are the ones that we need. All these are the hours. So total hours is equivalent to 24 multiplied by 5, then plus these 3 hours and a third. So 3 1/3 hours. So when you add these, you'll get 120 plus 3 1/3 hours, and this will give 123 1/3 hours. Now these are the total number of hours that will be there from Monday 8 a.m. to Saturday 11:20 a.m. Now for 1 hour, the clock loses 18 seconds. So what about for 123 1/3 hours? So how many seconds will be lost? Just multiply 123 and a third times 18. When you multiply these, you get 2220 seconds. So for ease of workings, we can convert the seconds to minutes by simply dividing the seconds by 60. When you divide that 2220 by 60, 2220 divided by 60, that will give 37 minutes. So for all these number of hours, 37 minutes will have been lost. Now, instead of reading the correct time at 11:20 a.m., it will have lost 37 minutes. So we subtract because it will have lost. So now it will read 10:43 a.m. 10:43 a.m. Question 10. In the following figure, line AB is equals to 5 centimeters is a side of triangle ABC in which angle BAC is equals to 120 degrees and line BC is equals to 10 centimeters. Using a pair of compasses and a ruler, complete triangle ABC and hence measure the size of angle ABC. So that is the question. Now for this particular line, I've tried to change the position of B since I've zoomed my page, and by zooming the page, I've interfered with the correct measurement. So B, the correct position of B, according to my diagram here, that should be the correct position, and I've taken the right measurement, that is 5 centimeters. So if I measure that to confirm, just to confirm, you can see that is indeed 5. Yeah, it is 5. So the angle that you're supposed to start by measuring, and you're supposed to use a ruler and a pair of compasses, is angle BAC. Angle BAC. So that means C is somewhere around here. BAC. So to have 120 on this side, I will have to extend this line AB. So let me extend line AB. Let me extend it. Can extend it maybe up to that point, so that I can construct at A an angle of 60 degrees to the left, and then to the right I will have 120. So taking a pair of compasses, standing at A, this is how you construct an angle of 60 degrees. So standing at A, so I want to construct an angle of 60 on this side, so that I can be left with 120 on the right hand side. So just mark a big arc there, then with the same radius, without changing that radius, come and cut that arc. So I'll have to stand there again. I have to stand there and mark that arc once again. So that is the arc. So I've made that arc, standing there, we made that arc, and then with the same radius, without changing it, you stand at this point here, that point, and then you cut that arc. You cut that arc like that. So that will give an angle of 60 degrees. Then join this point A with the point of intersection of the arc there, like that, and these will be 60 degrees. So these will be 60 degrees, and having 60 degrees, and this is a straight line, and the sum of angles on a straight line should be 180, then 120 will be here. Then after doing that, BC should be 10 centimeters. So how do I achieve that length? I'll take with a pair of compass, make sure you take 10 centimeters. 10 centimeters. So 10 centimeters, this is quite a long one. It will be quite a long one from my end. So that is 10 centimeters from My pair of compass, it is calibrated. You can see that is 10. In your case, you can take that one from your ruler. So that is 10 centimeters. And that means that I have to extend this on. I have to extend this line. I have to extend it up, maybe up to, yeah, like that. So that now, with that measurement, having that measurement, 10 centimeters, I'll stand at B. And then I will mark an arc along this line from A. So from A, that line. So with that is 10 centimeters standing at B with a measurement of 10 centimeters. Mark an arc on that line from A. So this will now be the position of, this point will be the position of C. Now, using a straight line and a ruler, so standing at B, you simply join that point like that, the point of intersection of the arc. So that is how you get point C. And I think everything is complete. What you need to do now is measure the size of angle ABC. Measure size of angle ABC. That is the angle that we need to measure. So this is the angle. We need to measure that angle there. So take your protractor to measure that angle. Take a protractor and then place it there. So let me try to increase it. You can see it. So you can see I've placed, ensure the center of the protractor is there. So the angle, you're measuring it from this side, so 10, 20, 30. And this is, you can see it is not yet 35, it is 34. 34. So 10, 20, 30, 34. So that angle is 34 degrees. 34 degrees. So that is 34 degrees. So angle ABC is equals to 34 degrees. So that is how you're supposed to solve that question. We can proceed to the next question. So the next question is here. That is question 11. A shopkeeper bought an item from a wholesaler. If the shopkeeper sells the item at 2740 shillings, he would make a profit of 3x Kenya shillings. If the shopkeeper sells the item at 2340 Kenya shillings, he would make a loss of 2x Kenya shillings. Determine the amount that the shopkeeper paid for the item. Read the question again if you find it is not clear when you read it the first time. So the shopkeeper bought an item from the wholesaler. If he sells the item for 2740, he would make a profit of 3x. So how do you get profit? Remember, profit is given by the selling price subtract the buying price. For you to make a profit, the selling price has to be higher than the buying price. So in this case, if he sells the item as 2740, so that means the selling price is 2740, then he would make a profit of x shillings, 3x like that. So we don't have the buying price, there. Then you go to the next statement. If the shopkeeper sells the item at 2340, he would make a loss of 2x. So how do you get a loss? For you to make a loss, of course, the buying price has to be higher than the selling price. So you take the buying price, subtract the selling price. That is how you get a loss. So there is a loss of 2x shillings, and we don't have the buying price, but we have the selling price is 2340. So now we have two equations here. The first one is here, and the second one is here. So look at these two equations. And you can see there's something common. Buying price, you can make buying price the subject. Make buying price the subject of the formula. Buying price will be given by, from the first equation, buying price will be given by 2740 minus 3x. You making buying price the subject, just ensuring that you have buying price on one side. Do the same for the second one. Buying price will be given by 2x plus 2340. So now you have these two equations and they are representing the same thing. Both of them have BP, or the buying price, as the subject. So because both of these equations are showing the same thing, buying price, so we can say these, we can equate them and say 2740 subtract 3x, that is buying price, and it is equivalent to the other buying price, which is 2x plus 2340. By doing this, we'll be able to get the value of x. How do you get the value of x? It will help us to get the amount the shopkeeper paid for the item, which is the buying price in this case. So like terms together, so we'll have 2740. I'm subtracting 2340 from both sides, so I'll have like that, and then I will add 3x to both sides. That is simply taking the like terms together. There is 2x plus 3x. So this will give 2740 subtract 2340. That will give 400 is equals to 5x. So therefore x, divide both sides by 5, you get it to be 80. Now when you get x, it will not be possible to get the buying price, which is the question. The question requires us to get the amount the shopkeeper paid for the item, which is the buying price. You can use either the first expression or the second one. So we'll use the first one. Buying price is equals to 2740 minus 3x. So which is 2740 minus 3x is 80. So this gives 2740 subtract 240, which gives 2500. 2500 as the buying price. Question 12. The following table shows the frequency distribution of marks scored by students in a mathematics test. The frequencies for two classes are not shown. The table also shows the height of each rectangular bar of a histogram drawn to represent the information on the marks scored by students. So the table is there and it has got marks, frequency, then the height of the bar. Calculate the missing frequencies. Calculate the missing frequencies. So you can see where the missing frequencies are in the two classes. So look at the first one. The first one is supposed to guide you. The first class, where we have 10 to 14, the frequency is 7, then the height of the bar is 1.4. So how has the frequency been obtained there? So when you look at these, and because this one is the table shows the height of each rectangular bar of a histogram. So this is the bar of a histogram. So in a histogram, you know that probably if you have the height of the bar represents the frequency density. The height of the bar is given by the frequency density. So definitely the height of the bar for this row, this is actually the frequency density that has been calculated in order to fill this particular row here. So we can confirm with the first one how frequency has been obtained. So how do you get frequency density? Frequency density is given by frequency divided by the class width. And you can give frequency as frequency is given by frequency density multiplied by the class width. So let's look at the height of the bar given here, the height of the bar, which I've said that represents the frequency density. So for the first class, it is 1.4. And the class width, how do you get the class width? 10 to 14. So you take the upper class boundary, which is a 14.5, then subtract the lower class boundary for that class. You subtract 0.5, that will be 9.5. So that gives 5. So the class width there is 5. So we multiply that by 5. And when you multiply that by 5, 1.4 times 5, you actually confirm that you get 7. So that one is confirmed. So this is the formula that has been used here. So that is what you're supposed to do for all the others. So calculate the class width, the class width of the others. 15 to 19.5. So simply take 19.5, that is the upper class boundary. You get the upper class boundary by just adding 0.5. Then to the upper class limit, then subtract the lower class boundary, take 15, subtract 0.5, that will be 14.5. So that gives 5 as well. Then the other one, the class size will be given by the upper class boundary, 29.5, subtract 19.5. So this also gives, now this one gives 10. You can see this one gives 10. This is quite a big one. That gives 10. So that is how you get the class width, by actually just taking the upper class limit, add 0.5, like for this class 29 plus 0.5, you get 29.5. Then subtract the lower class limit, subtract 0.5, you get 19.5. So for the second class, we will get it by simply taking frequency will be given by frequency density is 2 multiplied by the class width there is 5. So that gives 10. So that is 10. Then the other one, the other class, 2029, the frequency density is 1.5, then multiply by the class width, which is 10. So that gives 15. So that one is 15. And you're through. You've calculated the missing frequencies. Question 13. On the following grid, line A prime C prime is part of triangle A prime B prime C prime. Triangle A prime B prime C prime is the image of triangle ABC under a reflection along a mirror line. So you can see it there. So you can see the ABC is there, then A prime C prime is there. On the same grid, draw the mirror line and hence triangle A prime B prime C prime. Now, how are you going to draw the mirror line? Before you draw the mirror line, you're supposed to understand some few concepts here. Properties of reflection. One important one that is going to guide you in this question is that the mirror line should occur exactly between the object point and the image point. The mirror line should occur exactly between the object point and the image point. So I'm going to use A and A prime. You can also decide to use C and C prime. One is the object, the other one is the image. So I'll start by join A to A prime, like that, A to A prime. So the object is A, the image is A prime. So the mirror line should pass exactly between A and A prime, and it should be perpendicular. The mirror line should be perpendicular to that line. So that means for us to attain that, we should be able to construct a perpendicular bisector of A prime. That perpendicular bisector of A prime will represent the mirror line. So let's do that. So take a pair of compass. Take a pair of compass and stand at point A. So standing at point A, and open your pair of compass more than half of that line, A prime. So mark an arc, mark a bigger arc there, then down there, mark another arc there with the same radius without changing it. stand at point A prime, then cut that arc, and then cut that arc there. Then take a ruler and join the point of intersection of these arcs. Use a ruler. In my case, I'm able to use the tools here without having to use a ruler. Ensure from your end you must use a ruler to join these points. So ensure that your point, your straight line passes through this point and the other point. So that is the mirror line. You can see that the mirror line is passing exactly between the object point and the image point. Just need one. You can decide to use a C prime. I've just decided to use A and A prime. Another property is, if I let this point of intersection be represented by, I can name it X, then AX should be equal to A prime X. These distance should be equal. That means the object point and the image point are supposed to be equidistant from the mirror line. That distance is supposed to be the same, and that is what is going to guide us when we are getting the point that is B prime. When you're getting B prime, that is going to guide us. Then another thing that is going to guide us is that these mirror line should meet at 90 degrees. At 90 degrees. All these points, if look at A prime, that line is intersecting the mirror line at 90 degrees. So in order to get B, this is what you're going to do in order to get a B prime. So I will drop a perpendicular from B to the mirror line, because you can see even when you consider A, if you consider A here, look at A, this line is meeting the mirror line at 90 degrees. So I can stand at B and then I drop a perpendicular from that. I'm dropping a perpendicular from B to the mirror line. So standing at B, mark an arc there, then mark another arc there. Then from there, you can stand on this arc that you've made here. Stand on that arc that you've made there. Let me ensure that I'm standing there. So standing on that arc, there you can change the radius. So I mark another arc there, bigger one, and then I stand on this point here, the other point there, and then you cut that arc. Then using a straight line, use a ruler for this, you from B drop, join B to the point of intersection of, so from B to this line here. So you can see now you've dropped a perpendicular, and therefore this one is 90 degrees. Then remember what he said, that if this point, if we let this point to be X, this distance from B to the mirror line should be the same from the mirror line to where the B prime will be. From B to the mirror line, we take that distance, and it is very easy to check that distance. Actually, we can count the number of squares. We can count the number of squares here. So you can see from this point to this point, how many squares are these? So these are 1, 2. There are 2 squares. So you can see 1, 2. So B prime should be here. B prime should be here. You can take that distance using a pair of compass. So that is where B prime should be. So that this distance here, this distance should be the same from B to X, then from X to where B prime is. So I've just counted the squares. There are 2 squares here. There are 2 squares. So from this point to this point, that is 1 square, then 2. Then I counted from here 1 square, 2. So that is why it should be. So I can complete the. I can now complete the triangle so easily. Sorry for that. Can complete it. Just join it like that, and there it is. It is complete. So we've done the question and we're through with that. Question 14. The figure below represents a prism ABCDEFGH. The cross section of the prism is a trapezium. BC is equals to CF is equals to 5 centimeters. AD is equals to HE is equals to 2 centimeters. And AB is equals to DC is equals to 2.5 centimeters. Now, the question is, draw a labeled net of the prism. Draw a labeled net of the prism. So for you to draw the net, remember you have to draw this net accurately. All the measurements are supposed to be drawn as they are, and all the vertices are supposed to be labeled. Now, drawing the net from this prism means you want to open up this prism so that you can have a plane figure. So we start, we'll go face by face. So look at the base, BCGF. The base is a square of 5 by 5 centimeters. So we start by extracting the base. The base is a square, 5 by 5. So let me draw that square. So I'll draw the square very fast. Square, you have to draw this one accurately. So I'm trying to make this one easier to draw. So there we have, I have a square here. I just want to ensure that it is 5 centimeters. So I have to measure these. So let me measure. So I have to extend it. Yeah, now that is 5. The square measuring 5 by 5. And that is 5. So let me have it a little bit down there. So I can lock it there. So that is the base, which is a square. And this base is B. This is a BCFG. So let me label it B. So B should be here, B, C, and then FG. F should be here, F should be there, and G should be there. So that is the base. Now there is another face I want to extract. Look at this face, CDEF, CDEF, whereby you have this as 2.5, this is 2.5. So I want to have CDE. F. I want to have that plane. So when I open that, that will go to the right. So let me, so I have to measure. So it will measure 5 centimeters, 5 centimeters by 2.5 by 2.5. So that means I will have to measure 2.5. I have to measure 2.5 from here. So I have to measure 2.5 from there. So 2.5. So 2.5 is actually at that point, and then down here I should have the same. I should have 2.5 like that. Then you have to join this one. You need to be very keen like that. Very good. So now what I have drawn, I want you to look at the diagram there. So what I've opened up there is CF. You can see where CF is common, and then we shall have D and E. So D will be here. So D will be here. D will be here. And we have E will be on the side of F. E will be here. So E will be there. So now you can see that we have managed to have the 2 faces. So we have to now look at the other face. Now the other face is DAHE. DAHE. So the top part, I can shade these so that you can see it. So this top part, that is what I want to have. So of course it will share. DE is common. DE is common, that is 5. So I have to measure 2 centimeters. So this one, I'll have to measure 2 centimeters. 2 centimeters there. So I'll have to measure 2 centimeters. So now the face that we want to draw is DAEH. Hope you can see that, the one that I've shaded. Be careful with that. Now, to draw that face, I already have DE, which is 5 centimeters. So I'll need to draw this length. AD, 2 centimeters, and EH 2 centimeters. So that is a rectangle measuring 5 by 2 centimeters. That is what I want to draw. So 5 by 2. So I only have to draw 2 centimeters from here. So you just need 2 centimeters. 2 centimeters from E. So let me draw that. So from here I'll need 2 centimeters up that point. Let me draw it again. 2 centimeters up that point. And then down here, just need 2 centimeters. 2 centimeters up that point. And then from there, I'll draw a vertical line. Here it is, that vertical line. Yeah, that is done. So the face that I've drawn is, let me show you the face that I've drawn. This is DE. DE is there. So I have AH. On the side of D, I have A, and then this one is H. So before I proceed, let me indicate the measurements. So the measurements were, these was 5 centimeters. So this was 5 centimeters, 5 centimeters, 5 centimeters. This is 5 centimeters, 5 centimeters, 5. Then this was 2.5 centimeters, 2.5 centimeters. And then this is 2 centimeters and 2 centimeters. So I'm done with the right hand side. So now I need to go to the left hand side. So the left hand side, I need these, look at this rectangle, BGAH, BGAH. Note that that is what I want to extract, BGAH. So that is a rectangle measuring 5 by 2.5, 5 by 2.5. So I just need to measure 2.5 here. So I need 2.5. So I need 2.5. That is what I'm measuring. So from this point, up that point there, that is 2.5, and then yeah, 2.5. So 2.5 is there. So let me make this one straight. I've noted it's not straight. That one was not straight. So 2.5 up that point. Then you join. So I have to redraw these. I'll have to redraw these. Can measure that, or maybe I can measure it again. There is a side there that I have to repeat. Yes, there's a side. Let me repeat this side again. 2.5. Can repeat that once again. So 2.5. So 2.5 up that point. And then from here, so this one 2.5, and that is okay now. So there we have. So this is 2.5 centimeters. This is 2.5 centimeters, and this is 5 centimeters. Now we are done with that. Let me label. Can label these the side with B. This is AH. So we have A here. A is there, and then H is there. So you can look at the diagram to confirm that. Now what is remaining is the sides, where we have the trapezia, the two trapezia. We have trapezia BCAD and GFHE. Now for that trapezium, we have all the sides given, 2.55, 2 centimeters, 2.5. How do we construct that? We will require to have the height that is going to help us draw that trapezium very well. So the moment I get the height, I'll be in a position to draw that. So if I draw something like that, this AD being 2 centimeters, this one will be 2 centimeters as well. And then if that is 2 centimeters and the whole of BC is 5 centimeters, then we are remaining with 3 to be shared between these. So 3 divided by 2, this side will be 1.5, 1.5, because they are equal. Now the whole distance from B to C will be 5 centimeters. So 1.5 plus 2 plus 1.5. So now having these, we'll be able to construct that trapezium. And this is how we're going to do it. We're going to use a pair of compass to work out these. So we have, let me go to the sketch. The side where BC is, so standing at B, we have a measurement of 2.5. Standing at B, measurement of 2.5. Why are we taking 2.5? Because of BA. We are opening up that trapezium. So 2.5, so 2.5 is there. So with my pair of compass, you can see I already have 2.5. So with the 2.5, you can stand at B, standing at B, the 2.5, there it is, 2.5 is there. So with 2.5, you mark an arc. So I mark an arc there, the 2.5. And then standing at C again, standing at C, you also mark an arc. So mark an arc there, mark an arc like that. Then from there, we will need to have that height. So we need to get this height here. This one we have to do some calculations. This height, you have to get that height. And you're going to use Pythagoras theorem. So that height will be obtained by the square root of the hypotenuse squared. This is a triangle. Hypotenuse is 2.5 squared. Subtract the base, which is 1.5 squared. When you work out this using a calculator, this will give 2. So this height is 2. So that height is 2. So look at BC. We need to take a measurement of 1.5 from this side where B is, and then 1.5 from C. So 1.5 centimeters from B, we need to get that 1.5 from B. So standing at B, we take a measurement of 1.5. So there it is, 1.5, mark an arc. And then where we have C, again to turn this on. So from C, again 1.5. So 1.5 will be there. All right. So you can see why I'm making those points. I'm marking those points there because these sides, remember we have these 1.5. You can see that 1.5 which is here, and we have 1.5 here. So this one is 2 centimeters. So now the reason why we're getting the height is to help us now get the position of A, where A will be located. That is exactly why we were getting the height. So now, standing at this point, standing at this one of these arcs here, we will need the height because we need the height of 2 centimeters. Now we stand at this arc that we made here, this arc that we made, where we have 1.5, and then with the measurement of 2, that is the height of the trapezium. Now we cut this arc. So standing there, now we can cut this arc here. We can cut that arc like that, and then from the other side again, from the other arc there, we can also cut that arc like that. Let me see whether that one is correct. Let me to check something there. So from, let me see. Oh, I've seen standing at that with the measurement of 2. Let me see. Yeah, I've seen. Supposed to be. Now standing at that point, with the height of 2, I have a height of 2. Again, now you need to cut that arc. I almost missed the arc, but I can see it has touched that arc. Now, with that now done, you can simply join. You can join the point of intersection of these arcs using like that. You can join using a ruler, the straight line. So you can join the points there like that. And then you can also join B, the point of intersection. This one is quite challenging to use the tools. You have to be patient. And there we go. And then now from the other side now, from C, you also join like that. So you can see now we have the trapezium. It is challenging to use the tools that I'm using, but I'm trying my best. So we have BC, then AD. So here we have A and here we have D. So this is 2 centimeters. This is 2.5. This is 2.5 centimeters. That is the same thing that you're supposed to do on the other side of GF. On the other side of GF, remember what we did? That one now becomes easier because we have already done that. So take your pair of compass and we will start by marking. There are some points here we have to mark. So we're standing there. We mark 1.5. 1.5 centimeters. That is 1.5. So with 1.5 you mark there. And then on the other side, again, we make sure that we also mark that 1.5. So now, after marking 1.5, remember, we now take 2.5. Why are we taking 2.5? Because of GH and FE. So 2.5. Take a measurement of 2.5. With measurement of 2.5, standard G with 2.5. 2.5 is there. And then mark an arc there. Mark an arc. We make a bigger one like that. And then from the other end, from F, you have to mark another arc there. Measurement of 2.5. Then the height of the trapezia, this is where it comes in, 2 centimeters. It is 2 centimeters. So let me take 2 centimeters. 2 centimeters. I already have 2 centimeters stand at this point where you made that arc, and then cut that arc there. Okay, and then from the other arc that you made there, standard that arc there, you are getting the height of the trapezia, and then again cut that arc. Very good. Now you can take a ruler and complete your trapezia. So you start by joining G to the point of intersection G. So joining G, the point of intersection of the arcs, and then the other one is F. So the other one is F. So join F to the point of intersection of the arc. Other one didn't come out clearly. There it is. And then now completing the trapezia. There, you draw a straight line there. So now we have completed it. So we have G, H, E. So this one is H, this is H, and then this one is E. So this is 2 centimeters. This is 2.5 centimeters. This is 2.5 centimeters. So that is how you're supposed to draw it. Make sure that it is correctly drawn. You can see with the part that was a little bit complicated was construction of the trapezium, but I've demonstrated to the best of my ability how you're supposed to do that. So that is how you're supposed to solve that question. Question 15. In the following figure, triangle ABC is right angled at B, and AB is equals to 8 centimeters. D is a point on AC such that AD is equals to 5 centimeters, and the area of triangle ABD is 10 centimeters squared. The figure is there. You're supposed to calculate the length of side BC. So look at the triangles given there. What is going to help us in this question is triangle ABD. The reason is because you've been given the area as 10 centimeters squared. Now, how do you get the area of triangle ABD? Looking at the sides given, the formula that you can use to get that area is a half times the product of the two given sides, that is 5 by 8, and then multiply by the sine of the included angle, that is the angle between the two given sides. So when I use this formula, I'll be able to get this angle. Then after getting the angle, I will now consider triangle ABC. Since I have the angle and then I have one side AB, it will be easier for me to get the side BC. So the first thing, we begin by getting this angle. Once we get this angle, we'll be good to go. So to get that angle, as you said, we're going to take the area, which is 10. The area of that triangle, which is 10, is given by half times the product of the two given sides. I'm using this formula, the area of a triangle, where you're given two sides and an included angle. I'm using this formula where AB are the two given sides, and then theta is the included angle. That is the angle between the two given sides. That is the formula that I'm using. A half times 5 times 8, then times the sine of the angle theta, which I've indicated there. That is what is supposed to give 10. So we make theta the subject, sine theta the subject. So this will give 10 is equals to 20 sine theta. And then sine theta, if you divide both sides by 20, sine theta will be given by 10 divided by 20, which is a half. So for this one, sine theta is equals to 0.5. So theta will be given by, you get the sine inverse of 0.5, and this gives 30 degrees. 30 degrees. So this angle is 30 degrees. Now, after getting that angle, it will now be easier to get the required side, that is side BC. Reason, consider now triangle ABC. It is a right angle triangle, and you have AB 8, and then you have the angle. So you can use the trigonometric ratios. So the best one to use here, because you're given 30, so the side that you require is the opposite side to that angle, and then the given side is the adjacent. So you can use tangent. So tangent of 30 degrees is equals to the opposite. Now you're considering triangle ABC, the opposite side, which is BC, then the adjacent, which is AB, and AB is 8. So multiply both sides by 8, so you get BC is equals to 8 tan 30 degrees. 8 tan 30 degrees. That gives 8 tan 30 gives 4.6 centimeters. So that is how you're supposed to solve that question. We go to the last question in that section. The quadratic, that is question 16. The quadratic curve y is equals to 3x squared minus 4x passes through the point P1 negative 1. Determine the equation of the tangent of a tangent to the curve at point P, leaving the answer in the form ax plus by is equals to c, where a, b, and c are scalars. Now I'll just solve the question through sketching. Let's say this is the curve. That is the curve that you have, and then you require to get the equation of the tangent to the curve. Let's say the tangent is there. So that is the curve 3x squared subtract 4x, just a sketch, and then this tangent passes through the equation passes through that, then the tangent to the curve at this point. So this point here, the point to the curve where the tangent is passing, this is a point P, and that is 1, negative 1. So you're supposed to find or determine the equation of the tangent. Now, to get the equation of the tangent is a straight line. So you know how to get the equation of a straight line. You require to have at least 1 point and the gradient. So we have the point where the tangent is passing, that is 1, negative 1, but we don't have the gradient. So what will give us the gradient? We will get the gradient from the curve. So we'll get using the function of the curve, we'll be able to calculate the gradient function. If you want to get the gradient of this curve at this point P, the gradient of this curve at this point P, we shall get or obtain the gradient function. The gradient function, given the equation y is equals to 3x squared minus 4x, we get the gradient function by simply differentiating this function with respect to x. So differentiate 3x squared with respect to x, you get 6x. Then differentiate 4x, this will be 4. So this is the gradient function, and that is what is going to help us to get the gradient at this point P. So because we want to get the gradient at point P, and you can see the gradient function contains the x value, we will simply substitute the x coordinate of point P. The x coordinate of point P is 1. You can see 1, negative 1. So this is x coordinate, this is y. So the moment we substitute x is equals to 1 in this gradient function, we'll be able to get the gradient that will give us the gradient of the curve at point P, and that will be also the gradient of that tangent. So this will be 6, 2, subtract 4. And this will give, not 2, I'm sorry. This is 1. This is 1. X is 1. Then subtract 4. This will give 2. So the gradient of the curve at point P is 2. And that is also the gradient of the tangent. So the gradient of the tangent is also 2. The gradient of the tangent is also 2. And it passes through point P, 1, negative 1. So now we can get the gradient, the equation of that tangent by simply introducing another general point. Let's say you're introducing another general point, xy, on that line. Then use xy and p to get the gradient. So the gradient is given by change in y, subtract negative 1, then divided by change in x subtract 1 is equals to 2. So this gives y plus 1, then x subtract 1 is equals to 2. You can put this 2 over 1 and then you cross multiply. So this will be y plus 1 multiplied by 1, then 2 x minus 1. So this gives y plus 1 is equals to 2x subtract 2. So since you want the equation in this form, x and y should be on the left hand side, then the constant c should be on the right hand side. So I'll bring these to this side. So we'll get negative 2x plus y. Then I take positive 1 to the right hand side by simply subtracting 1 from both sides. So I'll get negative 2, negative 1. So this gives negative 2x plus y is equals to negative 3. You can leave it like that, or you can multiply each term by negative. When you multiply each term by negative 1, it will not change anything. Multiply each term by negative 1, you get 2x, subtract y is equals to 3. So that is the equation of the tangent in that form that is required. Let's go to section 2, 50 marks. Answer only 5 questions in this section in the spaces provided. I'll do all the questions for the purposes of explaining each and every question how we're supposed to do it. So let's begin with question 17. Question 17 is a question on speed and time and linear motion. So let's go through it. The road connecting town A and town B is 160 kilometers long. A lorry traveling at an average speed of 45 kilometers per hour left town A for town B at 11:50 a.m. At the same time, a car traveling at an average speed of 75 kilometers per hour left town B for town A. The two vehicles met at C, a town along the road. Part A, determine 1. The time when the two vehicles met. The time when the two vehicles met. That is the first question. So you read through again for proper understanding, and then you need to get some concepts when you're solving a question on linear motion. Now, we have the two towns here, and the two towns are 160 kilometers apart. So town A is there, and then we have town B is there. So the two towns are 160 kilometers apart, and we have two vehicles. The lorry is traveling at an average speed of 45 kilometers from town A to town B. That direction is very important. The direction of the movement is very important. I will indicate it here. So the lorry is traveling in this direction at 45 kilometers per hour. This is the lorry, and it left at 11:50 a.m. Then at the same time, that means at 11:50 still, the car traveling at an average speed of 75 left B for A. So the car is moving in the opposite direction. It is moving in the opposite direction. So I'll indicate that direction at the speed of 75 kilometers per hour. So this is the car, and it left at the same time 11:50 a.m. Now with that information, then the two vehicles met at C. C is a town, let's say somewhere there, just an approximation. C is there. They met here, a town along A and B. So determine the time when the two vehicles met. The time when the two vehicles met. Now, before you solve that question, you need to get the time taken for them to meet. How long did the two vehicles, the lorry and the car, take before meeting? How long did they take before meeting? That is what you're supposed to calculate. So time to meet is the first thing that you're supposed to calculate, and then that will help us to get the time when the two vehicles met. So time taken to meet. So time taken to meet is given by, when you have two bodies moving together, either in the same direction or maybe in the opposite direction, you have to get the relative distance. That is the distance between them. Relative distance. Then we divide by the relative speed. That is how we get the time taken to meet. Relative speed. You know how we calculate time? Time, you get it by distance divided by speed. But now you're using the relative distance. That is distance between them. And when you look at the distance between the two, because they began the journey at the same time, so at that time they were beginning, the distance between them is 160 kilometers. Then for the relative speed, looking at the direction of their movements, the lorry is moving from A to B, then car is moving from B to A. That is, they are moving in the opposite direction. So in such a case, to get the relative distance, we do add the two speeds. So 45 plus 75 kilometers per hour. So this will give 160 kilometers divided by, this is 120 kilometers per hour. So this one will get the answer in terms of hours, the hours taken. So 160 divided by 120, that gives 1 1/3 hours. 1 1/3 hours, or you can write it in terms of hours and minutes. So this is 1 hour and 20 minutes. That is the time taken to meet. Time taken to meet is the 1 hour 20 minutes. Now, to get the time when the two vehicles met now, you can simply either use the car. The car started at 11:50. The lorry started at 11:50. You just take the starting time is 11:50 and then add the time taken to meet. This is what is going to give you the time when the two met. So when you add these, you'll get 10. This is 13. So you either write it as 13:10 hours, or you can write this one in 12-hour clock system, which is the same as 1:10 p.m. So that is the time when the two vehicles met. That is all for that part. We go to the other part. Part 2, the distance in kilometers from town A to C. The distance in kilometers from town A to C. So you need to get this distance from A to C. That's very easy. How do you get the distance? Distance, you get it by taking the speed multiplied by the time. So which speed are we going to use? Is it the relative speed? No. We shall use the speed of the lorry. The lorry is the one that is going to give us the distance from A to C. Because we're moving from A to C, we are going to use the lorry is the one that was moving from A to B. So we can get the distance from A to C by taking the speed of the lorry, which is 45 kilometers per hour, and then we multiply by the time taken from A to C. C is the meeting point, and you have already calculated the time taken to meet. The time here is 1 1/3 hours. It is 1 1/3 hours. So within 1 1/3 hours, what distance was covered there? So 1 1/3 hour, you can write that as 4/3 hours. And this gives, when you multiply these, you'll get by 3, this is 15. 15 times 4. This gives 60 kilometers. 60 kilometers as the distance from A to C. So we've simply taken the speed of the lorry, that is 45, multiplied by time from A to C. We've already calculated that time. We go to part B. Part B, the car stopped at town C for a period of 1 hour and 40 minutes. The lorry continued with its journey at the same speed of 45 kilometers per hour. After the stop, the car left town C for town A and arrived at its destination at the same time the lorry arrived at B. Determine the average speed of the car for the journey from C to A. The average speed of the car from C to A. So again, I'll draw this one just to explain what is happening here. So we have A, then you have the meeting point is there, C, and then you have B. So the car, remember the car is moving in this direction. The car is moving in this direction. So first of all, the car moved up to the meeting point. We just calculate the time taken to meet from B to C. This is the car. It used the same time, 1 hour, 20 minutes. Then upon reaching at C, the car also stopped there for 1 hour and 40 minutes. And then it continued. It continued with the journey from C to A. Now we need to answer the question. Now from this distance, from C to A, what was the speed? What was the speed? And how do we get the speed? We'll get the speed by taking the distance divided by the time taken. So already we have the distance from C to A. We have it from the previous part, that is A part 2. We got the distance from A to C as 60 kilometers. So we have that. So that one is there. So what we are missing is the time taken from A to C. Now what is going to help us to get that time? We will be helped by this statement here. The lorry continued. The lorry did not stop. It continued with the same at the same speed of 45 kilometers per hour. And another thing that is going to help us is that after the stop, the car left town C to A and it arrived at its destination at the same time as the lorry arrived at B. So it arrived at the same time as the lorry arrived at B. So that tells us that the time taken by the lorry for the whole journey should be equivalent to the total time taken by the car. I'll write it here. Total time by the lorry for the whole journey should be equivalent to the total time by the car for the whole journey. Whether the car stopped or did not stop, that time that was taken by the lorry should be equivalent to the total time taken by the car, because we are given this statement, which is very important, that they arrived at the same time. They arrived at the same time at their respective destinations. So now we can get the total time by the lorry. So time by the lorry. So time by the lorry for the whole journey. How do we get time? We get time by taking distance over the speed. So distance is 160 kilometers. And then the speed of the lorry was 45 kilometers per hour. So this gives 160 divided by 45. This gives 3 and 5 over 9. 3 and 5 over 9 hours. That is the total time taken by the lorry. And that is what is going to guide us, because the car has to spend that time from B to A. It has to spend that. So now already the car has taken 1 hour, 20 minutes. And then it has also stopped for 1 hour. We have to calculate this time because we said the time has to be the same for them to arrive at the same time their destinations. So this is a 1 hour and 40 minutes still. So when you add the two, you notice this will give exactly 3 hours. So the car has taken 3 hours so far from B to C, 1 hour 20 minutes. Then resting there or stopping there is 3 hours. So what is remaining? The remaining time will now be the time from C to A. The remaining time will get the total time taken, which is 3 and 5/9, then subtract 3 hours taken. So this gives 5/9 of an hour. That is the time taken now at this point from C to A. From C to A, that is 5/9 of an hour. And that one now gives us an easy time when you're calculating the average speed of the car. So the average speed of the car, you simply come here and say the average speed is given by the distance from C to A, which is 60 kilometers, divided by the time taken, which is 5/9 of an hour. This gives 60 times 9/5. By 5, 1 by 5, 12. You get 12 times 9, and this gives 108 kilometers per hour. And that is simply how you're supposed to solve that question. Question 18. Figure VABCDEFGH shows a solid consisting of a right pyramid mounted on a rectangular block. The right pyramid and the rectangular block have an identical square base of length 6 centimeters. The height of the rectangular block is 10 centimeters, while VA is equals to VB is equals to VC is equals to VD is equals to 5 centimeters. So the figure is there. So part A of the question, calculate the volume of the solid. Calculate the volume of the solid. So as you can see, that solid is composed of two shapes. We have the top part, which is a right pyramid, and then the right pyramid means all the slant heights are equal. That is what you mean by the right pyramid. All the slant heights, as you can see, all of them measure 5 centimeters. And then we have the rectangular block. So now we start by getting the volume of the rectangular block. Volume of the rectangular block. And how do you get the volume of a rectangle? This is given by a rectangular block. That is what I mean. This will be given by length times the width times the height, which is 6 centimeters, times 6 centimeters, that is the base, and then the height is 10 centimeters. So this gives, that is 6 times 10, this will give 360 centimeters cubed. So that is the volume. Then we need to get the volume of the pyramid, the right pyramid. How do you get the volume of the pyramid? Of the pyramid is given by a third. This is the formula of getting the volume of a pyramid. A third multiplied by the base area multiplied by the height. So when you look at that pyramid, do you have the base? The base is there, is 6 by 6. But what you're missing is the height. So we need to calculate the height. And to calculate the height, we will have to, let me indicate the height. We have to draw that line, A to C. And then the height will be from V, from the vertex, that is V, straight down to the middle of that rectangle that is there, ABCD, or to the midpoint of line AC. So the height will drop from V to the midpoint of AC. So, and remember, these will meet that AC at 90 degrees to form 90 degrees. Let me name this point and the center here to be O. So for us to get the height, I will have to extract that triangle that you're going to use to get the height. So let me extract it here. So this is the point O, and then this is the right angle there. We have V, we have A. So AV is the slant height. That one we have, it is 5. Then we need to get AO. Now AO, we will only get it by using this triangle ABC. Triangle ABC is right angled at B because this is a rectangular base. Is a square base actually, 6 by 6. So that angle at B is 90 degrees. So we shall use this triangle ABC. It is right angled at B. We have 6 and 6. So AC, we use Pythagoras theorem. AC, because AC is the one that is going to help us to get AO, because AO is half of, I'll write it here, AO is half of AC. So once we get AC, automatically we'll be able to get AO. So AC, using Pythagoras theorem, AC is the hypotenuse. So using Pythagoras theorem, we shall have 6 squared, and the other side is 6 squared. So this will give the root of 36 plus 36, that is the root of 72. And that gives 8.485 centimeters. Now after getting AC, now it is easier to get AO. So remember, AO we said will be a half of AC. So already we have AC as 8.485. So we get a half of that. And you notice you get this as a 4.243. This here, I've indicated it here. So that is AO, 4.243, half of AC. So we calculated AC first, and then we get half of that. Now VO, which is the height that we require, using this triangle, we use Pythagoras theorem. It is the height, we need that height. So we get hypotenuse squared, Pythagoras theorem, minus the base squared, 4.243 squared. And then we get the square root of that. So this gives 25, subtract 4.243 squared. That gives 18. And so this gives the square root of 7. So this will give the root of 7. And the root of 7 will be 2.646 centimeters. So that is the height. Now we have the height of the pyramid. So we can now get the volume of the pyramid, which is that multiplied by the base area. The base area is a square, which is 6 by 6, as you can see there. Then multiply by the height, which is 2.4. We got it as VO. Is it 2.4 or 2.6? Yeah, we got it as 2.646. So that is how we get it. So these will be by 3.1 by 3.2. So when you multiply these, we will get 12 multiplied by 2.646. So this gives 31.75 centimeters cubed. So that is all about the pyramid. Now we get the total volume. The total volume of the solid will be given by the volume of the rectangular block, which is 360 centimeters cubed, plus the volume of the pyramid, which is 1.75 centimeters cubed. So we add these, and this gives 391.8. That is correct to 4 significant figures, centimeters cubed. So that is how you get the volume of the solid. We go to the next part. Part B. The solid is cut into 2 identical halves along the plane of symmetry VAFHCV. Calculate the surface area of one of the pieces. So the solid is cut into identical halves along the plane of symmetry VAF. Let me show that line of symmetry VA. So VA, that is the VAF HCV. So you can see that line of symmetry VAFHC. So that solid was cut along that plane of symmetry. So what are we going to have? If I will try to extract it here, the resulting shape will be something like this. Yeah, that is what we'll have. We'll have those faces. You need to be very keen because I've not included the others at the back. I'm just concentrating with the faces that you can see from one end. So these are the faces, and I'll name them. So this is a V. We will have that face. Then we have B there. We have C there, and then we have F, G, H. So these are the faces that you will have to calculate. Now, one face that you will not calculate, you need to be very keen with these, because these are solid, and when it is cut along that line, that face that I've shaded there, ABC, you will not include that one when it comes to calculating the surface area. The surface area, that one can't be seen. It is internal, and you may not be able to see that. So you're going to exclude that. That is the only one that you're going to exclude by the fact that this is a solid, and when you cut it, you do it practically, and these are solid. That face will not be visible, and for that reason, you're not going to include it. So the ones that you're going to include, I will calculate the area of each one of them. So let me start with the pyramid. From the pyramid, we will need face VAC. Yeah, we will need that face VAC, because we need to calculate that. So VAC, so we get that. So when you look at VAC, for VAC from the diagram there, we have 5, 5, and then we have the height of that. So we can use half times the base times the height, that triangle. So half, the area of that will be half times the base. The base will be AC, and we already got AC. AC is here, 8.485. Then times the height. The height is VO. The height of that triangle VO is 2.646. So that gives the area of that face. So let me calculate this. 8.485 multiplied by 2.646, and then we divide that by 2. So this gives 11.23 centimeters squared, not cubed, centimeters squared. You're through with that face. Then we can go to the other face, which is a VAB. Face VAB. Face VAB is the same with face VBC. They are similar. So these ones will be 2. We just get the area of 1. VBC. We get the area of 1, and then we multiply by 2. So for that one, V, we have all the 3 sides. So if I can try to extract it here, we have something like this. So this side is 6, 5, and 5. So we can use, that is a VAB, 5, 5, and 6. So we can use the Hero's formula to work out this. So let me use the Hero's formula. So I'll start by stating the Hero's formula. S minus A, S minus B, S minus C. That is the area using the Hero's formula, because you have 3 sides. That is the easiest one. So let me start by getting S. S is the average of the 3 sides. So 5 plus 5 plus 6 divided by 2, which gives 8. So now area will be given by S, which is 8, then S minus one side, which is 5, then this is 8. So 8 minus the other side 5, then 8 minus the other side 6. A, B, and C. A, B, and C. So this is side A, this is side B, this is side C. And then you get the square root of that. You get the square root of that, like that. So this one will give 8 times 3 times 3 times 2. You get the area of that. This will be the square root of 24 times 6. 144, which is 12 centimeters squared. So that is the area of VAB. So when there are two, you will multiply by 2 because there are two similar shapes. So these will give 24 centimeters squared. So you're through with that. So let's go to the other shape. The other shape is let me see whether we are through with we are through with the pyramid. So from the pyramid, those are the faces. There are 3. 1, 2, 3. There are 3. Now let's go to the cuboid. For the cuboid, we have AFGB. AFGB. The cuboid, we have AFGB. AFGB, which is similar to BGHC. 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 So both of those are similar. BGHC. You can see that BGHC from the diagram, and AFGB. They are similar. They are rectangles. And they measure 6 by 10. 6 centimeters, then 10. So 6 by 10. So we shall multiply. These will be 6 by 10, and then we multiply by 2. So these will be 120 centimeters squared, both of them. 120 centimeters squared, 6 by 10. Then do we have another phase? Yes, we have. We do have another one. We have the bottom one. The bottom one that is here. So let me mark it. It is here. This one, we need to get that face. So that one, we have 6. We have 6 there. And then we have this length. We had calculated this length. AC, this one will be the same. FH will be the same with AC. AC, and we got AC as 8.485. Like that. So we need to get that one. And since it is right angled, this one is a right angled triangle. It is right angled at B. So we can use the formula half base times height. So this is what you are getting. A, B, C, which is the same, similar to, if I draw a line here, if I draw a line there, you'll definitely see that this FH is the same with AC. They are both equal. So that is why I've indicated this one as 8.485, the same. And it is right angled at this point. So this is 90 degrees. So that is why I'm using half times the base times the height. So that one, the bottom. So let me write that face. So FGH. FGH will be given by a half times the base. The base is 6 and the height is 6. So this by 2, 1 by 2, 3. So this will be 18 centimeters squared. I think now we have all the faces that we need. So from the pyramid, we have how many faces? 1, 2. We excluded the one that I shaded there. 1, 2. Yeah, there are 3, and we got that. And then, so we can add. Everything is okay. I confirm everything is okay. Now the total surface area. The total surface area. So total surface area. So we have another face that is left out. So look at face FHCA or FACH. That is another face that we need to identify. That is the last one. So look at this face. That is the one that is left out now. FHCA. So that one. So let me indicate that one here. FACH. So that one is a rectangle measuring you can see this length. FH is the length. FH is the length, which is 8.485, which is similar to AC for 8.485, and then that is the width, and then the length is CH or AF, which is 10. So this gives 84.85 centimeters squared. Now we have all the faces. So the first one is there, then the second one we have it there, then the other one is there, then 18, and then the last one is there. So now get the total surface area of all the faces. So the first one, VAC, 11.23 centimeters squared. The second one is 24, two of them that we combined, centimeters squared. Then the third one is 120 centimeters squared, and then we have 18.00 centimeters squared, and then the last one 84.85 centimeters squared. So we add everything. 11.23 plus 24 plus 120 plus 18 plus 84.85. So that gives 258.1, correct to 4 significant figures, centimeters squared. And that is how you're supposed to solve that question. Question 19. Question 19 is a question on equations of straight lines. So let's read through and solve it. Two lines, L1 and L2, are parallel. Line L3 is perpendicular to both lines L1 and L2. Part A. 1. Line L1 passes through points A and B. The coordinates are given there. Find the gradient of line L1. So how do you get the gradient of a straight line given 2 points? Here you're given these 2 points of L1, and you need to get the gradient. So gradient, or denote gradient by M is the gradient, is equivalent to the change in the y coordinate divided by the change in the x coordinate. So the gradient of this line, we get the change in the y coordinate, 9 subtract 6, then divided by the change in the x coordinate, which is 3 subtract -3. So this gives 3, that is 9 subtract 6, and then 3 plus 3, that is 3 negative. So these two negatives gives positive, so you have 3/6, and this gives a half. So a half is the gradient of L1. Part 2. Line L2 intersects the x-axis at point C, -5, 0. Determine the equation of L2 in the form y is equals to mx plus c. So L2 intersects x-axis at point C, -5, 0. That means C is a point on line L2, and you need to get the equation of line L2. So to get the equation of a straight line, we need at least 2 points or 1 point and a gradient. So we only have 1 point, which is -5, 0, and we don't have any other point. So to get the equation, simply introduce a general point, let's say xy, on that line, and then we will get the gradient easily, and this is how we get the gradient. from the first statement, we're given that line L1 and L2 are parallel. That one will help us to get the gradient. When two lines are parallel to each other, then their gradients are equal. So that means the gradient of L1 is equals to the gradient of L2 because they are parallel. Parallel lines have equal gradients. So the gradient of this line L2, I'll denote it by M2, will be a half as well. This was the gradient of line 1. So now having the gradient and we have these 2 points, -5, 0 and x and y, we can get the equation. So let's get the gradient using these 2 points, -5, 0 and x, y. So change in y, that is y subtract 0 divided by the change in x coordinate, which is x subtract -5, is equals to the gradient, which is a half. So this gives y divided by x plus 2. This x subtract -5 is x plus 5, not plus 2. Sorry, plus 5. Then is equals to a half. Cross multiply these. So y times 2, you get 2y is equals to x plus 5 times 1, you get x plus 5. So from these, if you divide all through to give the equation in this form, y is equals to mx plus c, divide all through by 2, you get y is equals to x divided by 2 plus 5 divided by 2. That is the equation. We got part B. Line L3 intersects lines L1 and L2 at points A and P respectively. Part 1. Determine the equation of L3 in the form y is equals to mx plus c. So remember, line L1 and L2 are parallel to one another. So I'll draw them here. That is the line L1. This is line L2. They are parallel. And then there is another statement here. L3, line L3 is perpendicular. That means it meets both line L1 and L2 at right angle or at 90 degrees. That is what we mean by perpendicular. So L3, if I'm to sketch this, it's just a sketch. L3 is there. And L3 intersects these two lines at 90 degrees. It is perpendicular. That is L3. So it intersects L1 at point A. So this here is point A, which is -3, 6. And then P, it intersects line L2 at P. So point P is here. So how do we get the equation of L3? For us to get the equation of a straight line, we need 1 point. We have 1 point on L3. We have this point A on L3, which is -3, 6. So let us introduce another general point in order to get the equation easily. X, y on the same line. What we are missing is the gradient. This is how we get the gradient. Because L1, we know the gradient of L1 is a half, and you know the gradient of L2 is the same, is a half. This concept is going to help us. When two lines are perpendicular to one another, when two straight lines are perpendicular to one another, then the product of their gradients should give -1. So that means if I take the gradient of L1, which is M1, I multiply by the gradient of line 3. Let me call the gradient of line 3 to be M3. Those lines are perpendicular, then that product of the gradients of the two should give me -1. So the gradients of line 1 is a half, multiplied by the gradient of line 3, we don't know that, should give -1 because the two lines are perpendicular. So therefore, the gradient of line 3, which is M3, should be given by, just make M3 the subject, multiply this side by 2 and this side by 2, you'll be left on the left hand with M3, which will be -2. So M3 is equals to -2. Now with that, we'll be able to get the equation. We can get the equation of L3. So we have these 2 points. We have these 2 points here, and we have the gradient. So let us calculate the gradient using these 2 points, negative 3, 6 and xy. Change in y subtract 6 divided by the change in x subtract negative 3 should give negative 2 over 1. So this gives y subtract 6, x subtract negative 3 is x plus 3 is equals to negative 2 over 1. Cross multiply these, and when you cross multiply, you get y subtract 6 times 1, you get y subtract 6 is equals to negative 2 multiplied by x plus 3. So this gives y subtract 6 is equals to negative x subtract negative 6. So you're writing it in this form, y is equals to mx plus c. So add 6 to both sides to eliminate negative 6 from the left hand side. You'll have negative 2x plus this negative 6 plus 6 to be 0. So that will be the equation of line 3. The last part 2, determine the coordinates of point P. Determine the coordinates of point P. So look at the coordinates of point P. This is what we need. And point P is the intersection of these two lines, L2. It is the intersection point of line 2 and line 3. So how do we get the point of intersection? We will get the point of intersection by simply equating the y functions of the two equations of straight lines, or simply solving the equations of line 2 and line 3 simultaneously. That will give us the point of intersection, that is P of the two lines. So the equation of L2 of line 2 was here. It was y is equals to x over 2 plus 5 over 2. Y is equals to x over 2 plus 5 over 2. And then the equation of line 3 is negative 2x. Now, if you want to get the point of intersection of these two straight lines, you simply solve the two equations simultaneously. By doing so, you'll get the value of x and you'll get the value of y. And then once you get x and y, you write them in coordinate form, and that will be the point of intersection. So now, any suitable method that you're going to use to solve these two equations is okay. I will use, I'm going to equate these. This is y and this is y. Both of these are representing y. So we have y from y is equivalent to y. So we have the first value of y is given as x over 2 plus 5 over 2. That is y from line 2. Then also we have negative 2x. That one is equivalent to y. So you can see I'm equating the functions of y. Or you can simply substitute. You substitute y in either of the functions that you choose. You can take from equation 2, equation 1, this is equation 2. You can take y from equation 2, you substitute it in equation 1. Any method that you use to solve for x and y is acceptable there. Alright, so with this equation now, I can try to eliminate these two from the denominator. I multiply each term by 2, each term by 2, like that. And this gives x, here I'll be left with x, then here I'll be left with 5, and then this one will be negative 4x, negative 2x times 2. Then take terms together, shall have this is x plus 4x is equals to 5, so 5x is equals to 5, and therefore x is equals to 1. Once you get x is equals to 1, then to get y, just substitute it in this function. Y is equals to negative 2x. So this is negative 2, 1. X is 1. So y will be negative 2. So now with the values of x and y, that will give us the point of intersection of the two lines. The x coordinate will be 1 and the y coordinate will be negative 2. So that is how you get the coordinates of point P. Question 20. A transporter was contracted to transport 133 tons of sand from site A to site B. The transporter used 2 lorries, a 7-ton lorry and a 14-ton lorry. The transporter incurred a cost of 3,000 per trip for the 7-ton lorry and 4,000 per trip for the 14-ton lorry. The total cost incurred by the transporter was 47,000, part A, given that the 7-ton lorry made X trips while this 14-ton lorry made Y trips. Write down two equations to represent the information. Now the first equation will come from the first statement. The transporter was contracted to transport 133 tons. So how do you get the total number of tons? From the two lorries. You're given that the 7-ton lorry made X trips. So that means that in one trip, it carries or transports 7 tons. Because it is a 7-ton lorry. So what about for X trips? It will carry 7 multiplied by X. That is the total number of tons carried by the 7-ton lorry. Then we are getting the sum. The 14-ton lorry made Y trips. So that means in one trip, it transports 14 tons. So what about Y trips? It transports 14 multiplied by Y tons. So 7x plus 14y represents the total number of tons transported by the two lorries, which you're given is 133. That is the first equation. First of all, check before you proceed to the other one whether it is possible to simplify it further. It is possible. All these values 7, 14 and 133 divisible by 7. So divide all through by 7 every term. 7x by 7, you get x. Then 14y divided by 7, you get 2y. Then 133 divided by 7, you get 19. So that is the first equation. Now the second equation will come from this statement. The transporter incurred a cost of 3,000 per trip for the 7-ton lorry. 3,000 per trip. And the 7-ton lorry made X trips. So if for one trip it incurred a cost of 3,000, so for X trips it will incur 3,000 multiplied by X. Then for the 14-ton lorry, it incurred 4,000 shillings per trip and it made Y trips. So the total cost will be 4,000 multiplied by the number of trips, which is Y. So now this represents the total cost by the two lorries, and the total cost is given as the two lorries will be 47,000. 47,000. So that is the second equation. We can simplify this by dividing all through by 1,000. Divide every term by 1,000. 3,000 by 1,000, you get X. Then 4,000 divided by 1,000, you get 4y. And then this is 47. That is the second equation. You can simplify this one further. So the two equations are x plus 2y is equals to 19. And this is 3. Sorry, this is 3. 3x. 3x plus 4y is equals to 47. So those are the two equations they're supposed to have formed. Part B, use matrix method to solve the equation in A above. Using the matrix method, you're supposed to solve these. Now the first step, ensure that you have organized your equations so that these values, x values are corresponding, the y values are corresponding like that. Then you pick the coefficients of x and y. Look at the coefficient of x. The first one is 1. The coefficient of x in the second one is 3. The coefficient of y is positive 2. Coefficient of y in the second equation is positive 4. Then the unknowns that you're looking for, x and y, should be equivalent to 19, 47, like that. Now, we solve. That is the first thing you do. You organize. So to solve this equation, first of all, you get the inverse of 1, 3, 2, 4, this matrix. To get the inverse of that matrix, you start by getting the determinant of this matrix. This will get the determinant, get the product of the element of this diagonal, 1 multiplied by 4, and then subtract the product of this diagonal, 2 multiplied by 3. And this gives 1, this is 4 minus 6, this is negative 2. So the determinant is -2. The next step, to get now the inverse, you take the determinant. You have 1 divided by the determinant. 1 divided by the determinant. Then check how we interchange these values. These will be 4, -2, and then -3, 1, -3, 1. So check how these values are interchanged. Look at this diagonal. This is 2, 3, -2, -3. So the signs changes from these in this diagonal. Then look at these elements in this diagonal, 1, 4. What is happening? 4, 1. The elements are interchanged. So for this diagonal, you change the sign like that, and then the other diagonal there, you interchange. So let's get you multiply every element here by -1/2. -1/2 times 4, that will give -2. -1/2 times -2, that will give 1. -1/2 times -3, -1.5, that is positive 1.5. And then -1/2 times 1, -0.5. So that is the inverse. The next step, pre-multiply each side of the equation by the inverse. Each side of the equation by the inverse. So this is how you do it. Pre-multiply each side. So you take the inverse, which is -2, 1.5, 1, -0.5. So that is the inverse. So we have 1, 3, 2, 4. Then xy is equals to, the other side you do the same. The inverse is -2, 1.5, 1, -0.5, and then 1947. So that is what we mean by pre-multiplying each side by the inverse, of the matrix. So the inverse is here. So you multiply each side. This step must be indicated for you to score the marks. Now, there is one thing that you're supposed to note from this product here. When you multiply the two matrices, these are 2 by 2 matrices, these will give an identity matrix 1, 0, 0, 1. How do you come up with that? When you take a matrix and then you multiply that matrix by its inverse, you normally get an identity matrix. An identity matrix that is of order 2 by 2 is of this nature, 1, 0, 0, 1. That is an identity matrix. So 1, 0, 0, 1 is what you get when you multiply these. When you take a matrix, then you multiply by its inverse, that is what you get. An identity matrix has no effect when you multiply it with any other matrix. It's simply like multiplying anything by 1. When you multiply anything by 1, you don't change it. Now, where you have to be very keen is the right hand side. This is where you get the answer. When you multiply this 0 multiply by this column, this is -2 times 19, then plus 1 times 47. Then go to row 2, then add column 1.5 times, this 1.5 times 19, then plus -0.5 times 47, like that. So now, I just mentioned this, that when you multiply the left hand side, the identity matrix, by xy, you simply get xy, because the identity matrix has no effect. Then for this one, this will be negative, this will give -38 plus 47, and this will be 9. And then the other one is 1.5 multiplied by 19, that will be 28.5. Then this one -23.5. So the whole of these will be 28.5, subtract 23.5, that will be 5. So you've solved that. So x is equals to 9 and y is equals to 5. So these are the number of trips. So x number of trips for the 7-ton lorry, those are 9 trips, and then you have 5 trips. So that is how you're supposed to perform that. Now we go to the next part. Now the next part is supposed to answer this question. The transporter was paid 500 shillings per ton of sand delivered to site B. Calculate the amount of profit made by the transporter. There is a question. The transporter was paid 500 per ton. So whatever you need to do there, very easy question, because we already know the total number of tons that were delivered from the first statement. 133 tons were transported from site A to site B. And the cost per ton was 500 per ton. So if 1 ton, the transporter paid 500, what about 133 tons? So for 133 tons, you multiply these, 133 times 500. And then that will be the total cost. So you multiply that. Multiply by 500, and this will give 66,000. This will give 66,500. So that was the total cost. 133 tons were transported, and 1 ton costed 500 shillings. Then we're supposed to get the profit. We simply check the amount, the cost. The transporter incurred the total cost of 3,000 per trip. So the total cost incurred was 47,000. We have it here. The total cost incurred by the transporter was 47,000. So cost incurred, the cost incurred was 47,000. And this is what the transporter was paid. So you can see, you can now be able to calculate the amount of profit. So profit will simply be given by the amount that was paid, which is 66,500. Then we subtract 47,000. These was a 47,000. So this one gives a profit of 19,500. 19,500 as the profit, and that is how you're supposed to solve that question. Question 21. In the grid provided, the coordinates of points P and Q are 33 and 85 respectively. Vector PQ is also shown there. You can see there. Part A, express PQ as a column vector. Express PQ as a column vector. Now, how do you get PQ? You can see PQ is represented there. Now, to get PQ, we take the position vector of Q, that is OQ, then subtract the position vector of P. So that is how you get PQ. PQ, you take the position vector of Q, that is OQ, subtract the position vector of P. So we have Q. The position vector of Q is 8, 5. So write that one in column form. It will be 8, 5, like that. Then subtract the position vector of P. That is P is 3, 3. 3, 3, like that. And this gives 5. Then this is 2, 5, 2. So that is vector PQ as a column vector. Part B. Two vectors A, 3, -1, and B, -1, 4, as such that KA and HB is equals to PQ, where K and H are scalars. Determine the values of the scalars K and H. So this is how we're supposed to do it. We have KA Ka. So we have to take vector K and then we multiply by A. Vector A is here, 3, -1. So 3, -1. Then plus H. HB, B is -1, 4 is equals to PQ. We got a vector PQ in column form to be 5, 2. So you just write it there, 5, 2. Then from there, K, each of these elements here, K times 3, you open this bracket, you have 3K, then K times -1, -K. Then plus H times -1, that would be -H. Then H times 4, we have 4H, like that, is equals to 5, 2. Then from there, you can pick these elements in the first row. Let me call this the first row. So you have 3K subtract H is equals to 5 as the first equation. And then the second equation, you take the lower one, -K plus 4H is equals to 2. So you can see you have two simultaneous equations that you formed here. Solve these simultaneous equations using any suitable method. So I will use elimination method, and I will eliminate K. So look at this, 3K and -K. So I can multiply this by 3 and this by 1. So that I will have this one as 3K. So have this as 3K subtract H is equals to 5. So the second one, this will be, I multiply everything by 3. This will be -3K, then plus 12H is equals to 6, like that. So I want to eliminate K. This is 3K, this is -3K. So what should I do? I should add, not subtracting. 3K plus -3K, that will be eliminated. So add, not subtract. Then -H plus 12H, that will be -H plus 12H, that will be 11H, is equals to 5 plus 6, that will be 11. So H will be 1. H will be 1. So if H is 1, now you can substitute. I can use this equation here. -K, then plus 4H. H is 1, so that will be 4 times 1, which is 4, is equals to 2. And therefore, -K will be given by 2 subtract 4, -2, to be -2. And therefore, K will be given by 2. So K is equals to 2. That is how you're supposed to do that. So H is 1, K is 2. So that is how you're supposed to work out that. We go to the next. The next question is here. So on the grid, that is part 3, on the grid from point P, represent by accurate drawing the sum of vectors Ka plus H plus HB. Represent by accurate drawing Ka plus HB. Ka plus HB. So you have Ka plus HB. That is what you're supposed to represent. So let's go to, we already have it here. We have, let us first get Ka. We already have K. We obtain K as 2. So this one, we are going to take 2. And then A, we have A. A is 3, -1. Then plus H. H is 1. H is 1. Then B. B is -1. -1, 4. So for this one, we will have Ka, we will have 2 times 3. This is a 6. Then 2 times 1, 2 times -1, -2, and then plus, this will be -1, 4. So that is the first thing to do. Now, let's start with KA. KA, of course, we are starting from P. So from P, we take KA, we start with KA, and then we go to HB. So KA, beginning from this point, 6, we count 6, this is positive 6, so this will be 6 steps. 2 from P, 6 steps to the right. So 1, so from here we have 1, 2, 3, 4, 5, 6, like that. And then -2 means 2 steps downwards. 1, 2. So that is why we shall have the position. So let me represent this one by accurate drawing. So we'll have something like that. Let me demonstrate it again. So you have 6 from P, 6 steps or squares to the right, that is positive 6. So we have 1, 2, 3, 4, 5, 6. And then for -2, it will be 2 steps downwards. If it was positive, we would have added upwards. So this is downwards. So 1, 2. So this is where the arrow should be pointing. Then we add -1, -1, -1, 4. So -1, this is a displacement. The first value there represents displacement on the x-axis. Then the second one, displacement in the x-axis. You need to be very keen when you are adding this column vector. So the first value here, -1, represents the displacement in the along the x-axis. Then the second one, displacement along the y-axis. The same to the other one, 6, -2. 6 is a displacement along the x-axis. So if it is a positive, the displacement is to the right. If it is negative, the displacement is to the left. The same happens to the second one. Now, for example, -1, that is displacement along the x-axis. That is negative, that is to the left. Displacement 1 unit to the left. So from here, 1 unit to the left, and then 4 upwards. 4 upwards, we have 1, 2, 3, 4. So this one, we shall put it here. So that is the direction. So I'll present it again. So -1. So from here, we're adding it from here. -1 is that way, 1 step to the left. Then 4. If it is positive, the displacement to the y-axis is 4 units. 4 units. Upwards, positive. Then downwards, negative. So this is positive 4. So 1, 2, 3, 4. And that is how you are supposed to represent that. So this is KA. So this one represents KA, and this one represents HB. So that is how you're supposed to represent that part. The last part, determine the magnitude of vector KA. Vector KA. So vector KA, we already have it here. KA was, let me just repeat that. So KA was, remember we got the value of K as 2. So 2, 3, -1. 2, 3, -1. And these are supposed to be 6, -2. So you're supposed to find the magnitude of these. Now to get the magnitude, we get 6 squared. That is the x coordinate. Square that. Then the y, -2 squared. And then you get the square root. This is how you get the magnitude of KA. So this will be 36 plus 4. And you get this one to be the root of 40. And the root of 40 is supposed to be 6.325. That is correct to 4 significant figures, 325. So that is how you're supposed to solve that question. Question 22. In the following figure, lines AB is equals to 10 centimeters and AD is equals to 5 centimeters are part of a trapezium ABCD, in which line AB is parallel to line DC. Angle DAB is equals to 65 degrees. Now I've indicated the correct measurements since this is a scanned paper, it is not the original paper, and because of the zooming of the page, my units are not as indicated. That is why I've adjusted here. So the correct position of B, according to my measurements here, B will be there. So allow me to indicate B there, and then D will be this position that is here. That is the one that is 5 centimeters. And I can measure that to confirm. You can see that is exactly 5. That is exactly 5. AD is 5. And then let me confirm about AB. You can see AB is 10. So that is why I've just shifted the positions of D and B, so that we may not get different answers. Otherwise, the most important thing is to understand the steps that you're going to use in the construction. Part A, on the same figure, using a ruler and a pair of compasses only, you're supposed to ensure that you follow this instruction. Use a ruler and a pair of compasses only. Those are the two you can see there. I'm going to use these two. Complete trapezium ABCD, given that angle ABC is 67.5 degrees. Measure the length of line DC. So the main thing here is constructing this angle ABC, and that angle will be constructed here at B. How do you construct 67.5 degrees? Using a ruler and a pair of compass. How do you do that? Now, the easiest way, there are several ways you can use to get 67.5. I will specifically use construct 90 degrees at B, and after constructing there is a 90 degrees at B, I will have to bisect. If I bisect 90 degrees, I'll get 45. I'll get 45 there. And then I'll have to bisect the other half, 45 degrees that is here. I'll bisect that. So that these now will be, when you bisect 45, you'll get 22.5. Now you can see, when you add these 45 degrees plus 22.5, see 45 degrees plus 22.5, I will end up with 66.5. That is 6.5 degrees, the whole of this angle. So that is the method that I'm going to use. So I'll start by constructing 90 degrees at B, 90 degrees at B. So take a pair of compass. This is how we construct 90 degrees. Stand at B using a pair of compass. Any convenient length of your choice. I'll have to extend this line. Let me extend this line for the purposes of me extend this line so that it will be easier for me to mark the arcs. So using any convenient length, stand at B, and then with that radius, mark an arc there, and then mark another arc there, like that. And then you can now adjust and then stand on this arc that you made here, stand on that arc that you made, and you can open any radius of your choice, then mark an arc there with the same radius, stand at the other arc, and cut that arc there. So that is 90, that will be 90 degrees. So if I drop, that will be 90 degrees. If I join point B, the point of intersection of those arcs, I'll have 90. Then the next thing, I'll bisect 90 degrees. So standing at B again, standing at B, any convenient radius, may just a little bit, any convenient radius, mark an arc there, and then with the same radius, mark an arc there. Then from there you can adjust, then stand on this arc that you made here and mark an arc there with the same radius, stand at the other arc, and then cut that arc like that. Then using a ruler, straight line, join that point like that at the point of intersection of those arcs. Just make sure that this one is 45. Let me join this one again. So from this point, it will be there. So join. So that is 45. That will be 45 degrees. So this is 45 and this is 45 degrees. Then from there, I'll have to bisect this angle that is here. I bisect this one again. Let me bisect it. So I'll stand at this point once again. I stand at this point, stand at that point. Any convenient radius of your choice. Mark an arc there, and then mark another arc there. Then from there, you can adjust your pair of compass. You stand on this arc here that you made, and then cut that arc, and then stand on the other arc there, stand on that arc, and then cut that arc. So again, join that point with like that. So that is let me do it properly. I have to be very careful. You're supposed to use a ruler for your case. I'm able to, from my side, I'm able to draw straight lines without using a ruler. Ensure from your end you use a ruler to draw those straight lines. Now I've bisected that, and therefore now I have 22.5. I have 22.5, and this is 22.5. So now the whole of this angle, this is 45 plus 22.5, that is 67.5, the whole of that angle that is there. So that is the required angle. So now having that, the only thing that I miss now is I have, for that trapezium, I have point A. I have point A is here, point B is there, point D is there, but point C is the one that is missing. So how do I get point C? And remember that line that you're going to draw from D to this line, the one in red, should be parallel to the other line, because this is a trapezium, should be parallel to AB. So you need a line from D to this line that will be parallel to AB. So how do you do that? There are several ways of doing that. For me, I will transfer this angle at D. I will transfer that angle to D. So let me first extend. Line AD. Let me first extend it. I'll extend it like that. Then I will transfer this angle here 65 to D. And this is how you transfer that angle. Is another way, just one of the ways you can use this. So I will stand at A. So standing at A, any convenient radius, I will mark an arc. I will mark an arc like that. And then with the same radius, I go at D. I'll stand at D with the same radius. I'll go at D, and then I'll mark another arc like that. Then from there, let me adjust. You need now to take this angle. Take this measurement here. You see this angle here. Take this measurement. You take that measurement. You see that length there. Take that length using a pair of compass. Make sure you take that length. Take that length. You can see the length that I'm taking. I'm taking this from this point to this point. I'm taking that. So you need to be very keen with that. Take that length. Then that is what you're supposed to transfer. You're supposed to transfer to D. To D here. That is what you're supposed to transfer to D. And then you will simply, not at D, sorry, not at D. You transfer it here where you made this point here, not D. You transfer that angle, this point, because you've taken this angle. This is the angle that you've taken. Let me just bring it back for purposes of understanding. That is what I've taken. I've taken that length. You can see the length I've taken. So that is the length. And then transfer it, take it here, standing there, you have to mark an arc. You mark an arc, you cut that arc. You can see you've cut that arc, and the point of intersection is there. Look at that point. Then join now D to the point of intersection of the arcs. You can see that. So let me join. So from D, you join that like that. You join it like that. So you've joined D through that point of intersection. So by doing so, you've managed to draw or construct a line that is parallel to, so this line that is, so this is the point, this point here, before I proceed to that, this point here is the one that will be C. This will be point C now. We have identified point C. So point C is there, and DC is parallel to AB. The reason why I have transferred that angle, because if this line DC is parallel to AB, then AD acts as a transversal, and this angle, which is here, which is already given as 65, should be equivalent to this angle. That is why I transferred that angle to that point, that is 65. Those are corresponding angles. If DC is parallel to AB, then AD acts as a transversal, and this angle 65 is equivalent to that 65 there, that angle there. They are corresponding angles in a transversal. And that is the method that I've used to draw a line that is parallel to AB through D, passing through D, and it is parallel to AB. That is how I've got that line. So that is just one of the ways. There are several other ways you can use to construct a parallel line. That is the easier one. For me, I will recommend use that, or any other that you find convenient to you. Measure the length of line DC. So let us measure the length of line DC. So length of line DC. So that one I can use a ruler. Let me use a ruler to do that. So DC, I can see from my end, I may not be very accurate. I'm trying. Mine is approximately 6 centimeters. This is giving 6 centimeters. It is here. I can see this is 6 centimeters. That is what you're supposed to get. So this is 6. This is 6 centimeters. So 6 centimeters is the length. Now the other question, drop part 2. Drop a perpendicular line from D to meet AB at E. Drop perpendicular from D to meet AB at E. Now this is how you drop a perpendicular from D. So standing at D, using a pair of compass, I can extend this line. I can extend this line as well. This line that is here, me extend it. Line AB, can extend it. So standing at D, and you can mark, when you're dropping perpendicular, you can mark the arcs on that line AB extended. There is no problem with that. So I mark that from D, and then I draw another one there. Then from there, you stand on the first arc that you made there. Stand on the first arc that you made there, and then you can adjust if you want. Then mark an arc there. Then on the other arc that you made there, then you cut that arc. Then using a ruler, join point D, join D, join it like that, join D to the point of intersection of the arcs, and that line is supposed to meet AB at E. So this point here is E. This point is supposed to be E, and then this is supposed to be 90 degrees. You're supposed to measure the length of line DE. Measure the length of line DE. So let us measure that. I can use a pair of compass to do that from my side. So let me see whether it is possible to do that. So I'm using my pair of compass to measure that. Mine is calibrated. So I can see mine is 4.5. So this line here, this is 4.5. So DE is equals to 4.5 centimeters. You can use a ruler to confirm that. My pair of compass is calibrated. That is why I didn't use a ruler. So you can see it is 4.5. It is 4.5. Then the other question, part 3. Draw an arc of a circle, center A, radius 5 centimeters. The clockwise directed arc should join D to a point F. On line AB. So take a pair of compass and stand at A. A should be the radius, and then 5 centimeters. The radius should be 5 centimeters. That is why it must it should be made clockwise. Should join D. So if it's supposed to join E at D, so standing at this point, then 5 centimeters is up to that point. So I've taken 5 centimeters. Then you're supposed to draw an arc. Draw an arc from D. Sorry. So draw an arc from D. Draw an arc from D. Clockwise. That is the direction. That direction is clockwise. The one that I'm making the arc. And then it should join AB join AB at F to a point F on line AB. So this point that is here, this is supposed to be F. That point is the one supposed to be F, that point. So that is just 1 mark. We are through with that. And then part B of the question, which is the last one, calculate the area of the trapezium ABCD that lies outside the arc drawn in A3, outside the arc. So the area that we need, that is outside of the trapezium that is outside the arc, is this area that is here. So this is the area that we need to get. That is the area that is outside, the area of the trapezium that is outside the arc. So that is the one that we need. That is the area that we need. So how do we get that area? Now, to calculate the area of that shaded part, that is the one that is outside that arc, we will need to get the area of the trapezium ABCD. Then we subtract the area of the sector ADF. So I'll write it here. So we'll get the area of trapezium ABCD minus the area of sector ADF, that sector. That is when we remain with that. So this is area ADF. So let us get the area of the trapezium. The area of trapezium ABCD. You know how we get the area of the trapezium? Half times the sum of the two parallel sides. The two parallel sides is DC, which is 6 centimeters, and AB, which is 10. That is 10 plus 6. That is 10 plus 6. Then times the height. We calculated the height. The height is DE, and we got DE to be 4.5. So we work out these. Let us work out these very fast. We work out these, and this is so this will be a half times 16 times 4.5. So this will be 16 times 4.5, and then we divide that by 2. This will be 36. So you get 36 centimeters squared. Then the area of the sector ADF. How do you get the area of the sector? We get it by the angle in the center, that is theta, over 360 pi r squared. So we have the angle. The angle is 65 degrees divided by 360 times pi, 3.14 to use the pi given, times the radius. The radius is 5. So we'll take the radius to be AD, that is 5, and also AF, that is 5. So that will be 5 squared. That will be 5 squared. Yeah, I think that is okay. Theta over 360 pi r squared. That is okay. So you work out that so that you can get. So this will be 65 multiplied by 3.142 times 25 divided by 360. So this gives 14.18. Writing this one correct to 4 significant figures, centimeters squared. So now the required area will now be given by the area of the trapezium, which is 36 centimeters squared. Then subtract the area of the sector, which is 14.18 centimeters squared, 21.82. So we'll get 21.82 centimeters squared, and that is simply how you're supposed to solve that question. Question 23. The quantity of petrol in liters used by 40 border riders on a particular day is as follows. So the data is there. The cost of 1 liter of petrol is 160 Kenyan shillings. Part A, starting with 1.5 liters and using a class size of 0.5, draw a frequency distribution table for the data. A frequency distribution table for this data. So let me draw the table. Right away. So we have the classes. So let's put the classes here. We're supposed to have a class size of 0.5, and you're supposed to start with, the first one should be 1.5. So 1.5 should be the first one. So 1.5 2, if we must have a class size of 0.5, Then the other one will go to 1.5 to 1.9. Now this is how we get a class size of 0.5. If you want to get the class size of 0.5, you'll add from 1.5, you add 0.4. And this is the reason. When you're getting the class size, let's say from 1.5 to 1.9, to get the class size of the class width, you take the upper class boundary. The upper class boundary is 1.9 plus 0.05, so it will be 1.95. Then the lower class boundary, you'll take 1.5 subtract 0.5, so it will be 1.45, and that is when you get a class size of 0.5. So you simply take the upper class boundary, and you get the upper class boundary by taking the upper class limit 1.9, add 0.05. Then the lower class boundary, you take the lower class limit, that is 1.5, subtract 0.05. So that is how you're supposed. So the next one, if we look at the highest here, the highest value, the largest value here should be, is it 4.3? 4.3. I think that is the highest I can see there. So therefore I can proceed. The next one will be 2.0 to 2.4. Then the next will be 2.5 to 2.9. Then the next is 3.0 to 3.4. Then 3.4 to 3.9, and then 4.0 to 4.4. Now that is all. Those are the classes that you're supposed to have. Since I've considered the highest, the largest I can see there, 4.3. Then you shall have the frequency. The frequency, you count from 1.5 to 1.9. Any value that is between 1.5 and 1.9. So we can identify them. 1.5 to 1.9. So we have 1 there. We have 2. We have 3. We have 4, 5, 6, and 7. So there are 7. That is 1.5 to 1.9. Any value that is between that range. Then from 2.0 to 2.4. 2.0 to 2.4. 2.0 to 2.4. So we calculate that. 2.0 to 2.4. We have 1 there. 2, 3, 4, 5, 6, 7, 8. So there are 8. Then 2.5 to 2.9. 2.5 to 2.9. 2.5 to 2.9 again. 2.5 to 2.9. Have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11. Then 3.0 to 3.4. 3.0 to 3.4. You have 1, 2, 3, 4, 5, 6, 7. Let me see. 3.0 to 3.4. 1, 2, 3, 4, 5. Oh, this one that I've included there, 3.4. I've included 3.5 is not supposed to be there. So 1, 2, 3, 4, 5, 6, 7. There are 7. They are 7. Indeed, there are 7. There are 7. 3.4 to 3. And now the next one is 3.4. 3.5. 3.5. 3.5 to 3.9. There's something here I have to correct here. So it's supposed to be 3.5 to 3.9. So let me calculate those ones. 3.5 to 3.9. 1, 2, 3, 4. Yeah, so those ones are 4. They are 4. And then the last one is easy to identify. 4.0 to 4.4. 4.0 to 4.4. 4.0, we have 1, 2, 3. There are only 3. So there are only 3, and we are done with that. So to confirm, you must add, because these are 40 border riders. So you have to confirm the total frequency should be 40. total frequency should be 40. This is 7, this is plus 15, 26, 33, 37, 40. It is okay. So that is all. You can include the tally. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3. So that is the frequency distribution table. It is complete for the data as required. That is how we're supposed to do that. Now from there, we can go to the next question. Use the frequency distribution table in A to estimate the mean amount of money spent on petrol by boda boda riders on that day. The mean. How do you get the mean? Now to get the mean, we will need to use this formula. So mean is calculated by getting the summation of fx divided by the summation of f. So we will need to have another column here of frequency multiplied by x. And before we get fx, we need to get x. Then we get fx. X is the midpoint. X will be the midpoint of these classes. X will be the midpoint of these classes. So we get the midpoints. So this is how we get the midpoint. For example, the first class, 1.5 to 1.9, you simply add 1.5 plus, so 1.5 plus 1.9, and then you divide by 2. You divide by 2, you're getting the midpoint. That will be 1.7. You get 1.7. So use a different pen here. So you get 1.7 for that class. The other class, 2.4 plus 2.0, and then you divide by 2. That will be 2.2. The next one, 2.5 plus 2.9 divided by 2, you get 2.7. So there's something that you notice, that you are adding the class size. The first midpoint is 1.7. To get the next, you simply add 0.5. So 1.7 plus 0.5, you get 2.2. Then 2.2 plus 0.5, you get 2.7. So you actually, if the classes, all the classes are uniform, you simply add. To get the midpoints, you simply get the first one, then you add 0.5 to get the next value. So 1.7 plus 0.5, you keep adding that. 2.7 plus 0.5, this will be 3.2. 3.2 plus 0.5, 3.7. 3.7 plus 0.5, 4.2. So that is the column that we require. Now we need to get the product of frequency multiplied by x. So the first class, 7 multiplied by 1.7. 7 multiplied by 1.7, that gives 11.9. Then the next is 8 times 2.2, that gives 17.6. And then the next is 11 times 2.7, 29.7. And then the next is 7 times 3.2, 22.4. Then 4 times 3.7, you get 14.8. Then 3 times 4.2, 12.6. So that is what you get. Then after that, you have to get the sum of that column, the summation of fx. We add everything. So 11.9 plus 17.6 plus 29.7 plus 22.4 plus 14.8 plus 12.6, you get 109. 109. And then total frequency, the summation of frequency, that one you know it is 40. So now getting the mean will be given by 109. That is the summation of fx divided by the summation of f, which is 40. So 109 divided by 40, this gives 2.725. And this is the mean number of liters. The mean number of liters. So that is what you're supposed to get. But now the question is the mean amount of money spent. So to get the mean amount of money, what we got is the mean amount of petrol that is used on that day. So now to get the amount of money spent, we shall go back to this statement there. The cost of 1 liter is given here. The cost of 1 liter is 160. So 1 liter is 160. So what about 2.725? So that is why you have to multiply 2.725 multiplied by 160. So we multiply times 160, and this gives this one will give 436 shillings. 436 shillings. That is how you're supposed to work out that part. Let's go to part 2. The median amount of money spent on fuel by the median boda rider. By the median boda rider. So the median amount of money. The median amount of money. So we start with that. How do we get the median amount of money? So the first thing, we shall get the median amount of petrol that was used, because when we get the median boda rider, that will help us to get the median amount of petrol that was used, and then from there we shall get the median amount of money spent. So to get the median amount of petrol used, first of all, we will get the median position. The median position is given by, you take the total frequency, all the boda riders are 40, and then you divide by 2. Median is the middle position. So the median amount of petrol will be given by the 20th boda rider. 20th boda rider. So to get the 20th boda rider, we need to have another column here of accumulative frequency, so that it can help us identify the class where the median amount of petrol will be. The median class. So cumulative frequency, you know how to do this. So the first one is 7. So 7 plus 8, you get 15. 15 plus 11, you get 26. 26 plus 7, you get 33. 33 plus 4, you get 37. Then 37 plus 3, you get 40. So where do we have the median boda rider? That is the 20th. The 20th boda rider is the one that is going to give us the median petrol. So where is that? The median will be located here. 20th boda rider will be here, to be that class. So the class therefore is this. So this is the class. This is the class that we shall have there. Is that no? I think that was the class. We have these. Me go back. So 26 is in this class. Need to be very keen. It is in this class. So this is the class 2.5 to 2.9. So the position of the median boda rider will help us get the median petrol that was used. So now we have the class where we shall have the median boda rider. The class is 2.5 to 2.9. 2.5 to 2.9. So 2.5. So median class is equals to 2.5 to 2.9. So from there, now to get the median amount of petrol used, we shall use this formula. The median of this type of data, we are going to use this formula. This is the formula that you're going to use of calculating the median of a group data, where L will be the lower class boundary of this median class. So this class, the lower class boundary will be 2.45, the upper class 2.95. So this will be, so L will be 2.45. So this will be 2.45 plus N is 40, total frequency, divided by 2. So N is 40. Then CF is the cumulative frequency above the median class. The cumulative frequency above the median class is this one. This is the median class. The median class is here. That is where the median class is. So the cumulative frequency above that class, CF, is 15. So that will be 15. So subtract 15, then divided by the frequency of the median class. The frequency of the median class is here. It is 11. It is 11, like that. And then everything multiplied by the class size. The class size, we get it by, we already got it is 0.5. You simply use this. You can use this to get the class size. 2.95 subtract 2.45. Upper class boundary subtract the lower class boundary. The class size is 0.5. The class size is 0.5. So multiply this by 0.5. It is as simple as that. So now use the calculator to work out this. It's quite easy. So you shall have 2.45 plus, this will be 20 subtract 15, that is 5, divided by 11 times 0.5, like that. So this will be 2.5 plus, this will be 5 divided by 11 times 0.5. This will be 0.2273. So when you add this plus 2.45, you get 2.677 liters. So what we have is the median fuel. This is the amount of liters that is consumed by the median boda rider. So now still we have not yet got the amount. So we have the median amount of liters used by the median boda rider. Now what we need to get is the amount. So to get the amount, because we have 1 liter cost 160, so what about 2.66? So 2.677. So you multiply that by 160. So you multiply that by 160, and this gives 428 and 36 cents and 36 cents. That is how you're supposed to solve that question. Question 24. Figure ABCDEF represents a plot of land. Length AB is equals to 50 meters, BC is equals to Y meters, CD is equals to X meters, and DE is equals to 40 meters. The figure also shows an adjacent plot of land, BCDG. All angles in the figure are right angles. So the figure is there. You can see all the measurements indicated. The owner of the plot ABCDEF later purchased plot BCDG. Given that the perimeter of the plot BCDG is 60 meters, A, part 1, write an expression for y in terms of x. We can start with that. Now, given that the area of, not the area, but the perimeter of this plot BCDG, this is the one that we're given the perimeter BCDG, and you have the length is x, the width is y, and it's 60. So how do you get the perimeter? So that means this is x also, and this is x meters, and this one is also, this is y meters. So to get the perimeter, you simply add distance, total distance around that shape BCDG, and this is what you're going to do. So perimeter, which is 60, perimeter which is 60, is given by 2x, because we have x from BG and x from CD, that is x plus x, and then 2y from BC plus DG. So those are 2y. That is a perimeter. Or you can add the total distance around, x plus y plus x plus y. That gives 60. You can simplify this by dividing all through by 2. You get x plus y is equals to 30. That is a simplified expression. Part 2. Write down a simplified expression in x for the area of the entire plot of land AGEF. The area AGEF. But you need to be very keen. It is an expression in x, not in y, in x. AGEF. AGEF is the whole. AGEF, the whole of that. So the whole of that plot, we get the length. Let's identify the length. So the length will be given by 50 plus x. 50 plus x meters, and then the width will be given by 40 plus y. 40 plus y. 40 plus y. And since we need to get the simplified expression for the area in x, therefore we need to find the substitution of y, this y here. And you're going to use the first equation. So from the first equation here that we got in the previous part, that is part 1 of the question. We got x plus y is equivalent to 30. So we can make y the subject. Y from this one will be given by 30 subtract x. So now we can substitute these. We can substitute these for the width. So for the width, we shall have 40 plus y. Y is given by 30 subtract x. So width will therefore be 40 plus 30 to be 70 subtract x. So now with that, we have the length and we have the width. So area of that rectangle is given by length multiplied by the width. So you have the length. The length is 50 plus x. And then the width is 70 minus x. Multiply these, 50, 70, subtract x, then plus, just expand these, x, 70 minus x. This gives 50 times 70, that is 3500, subtract 50x, plus 70x, then subtract x squared. So this one gives area is equals to 3500 negative 50x plus 70x, that gives 20x positive, and then minus x squared. So that is the simplified expression for the area of the entire plot AGEF. Part B1. Determine the dimensions of the plot BGDC that would maximize the size of the entire plot of land AGEF. Now this is application of differentiation. Simply because if we want to get the dimensions of the plot BGDC, simply check that BGDC, it has the dimensions of x and y. We need to get x and y. That will give, would maximize the size of the area of the entire plot that we've just obtained. Remember, we have the area of this plot. Then it means for us to get the dimensions that would maximize the size of the entire plot of land, this one, we are going to use application of differentiation. And this is the concept that you're supposed to know there, that at maximum or minimum area, at maximum or minimum area, we take dA over dx. That means if we differentiate area with respect to x, we should get 0 at maximum or minimum area. When you take the expression that you're given for the area, we differentiate that one with respect to x, we should get 0. So already we have the expression here of area is 3500 plus 20x subtract x squared. So now at maximum or minimum area, if we differentiate area with respect to x, we differentiate these, that 500, that one will be gone, 20 x. When you differentiate that, you get 20. Then differentiate negative x squared, that will give minus 2x. So at maximum or minimum area, these should be equivalent to 0. So 20 minus 2x should be equivalent to 0. And therefore, x here will be 10. The dimension that is going to give us the maximum area of that plot will be 10. So x is 10. So we have 10. So we now need to get y, because we need to get the dimensions of that plot. It has x and y. So we can use any of the equations. The equation we got in the first part, x plus y is equals to 30 from the first part. So since x plus y is equals to 30 and we have x as 10, then y will be 20. So we have the dimension. The dimensions are x should be 10 meters and y should be 20 meters. Those are the dimensions that will maximize the size of the entire plot of land. Then after getting that, now determine in meters squared the maximum possible area of the plot. So therefore, because we have the dimensions that will give the maximum area, now we use the dimensions. So remember the length was of that plot AGEF was 50 plus x. 50 plus x. Then the width, we got the width as 70 minus x. 70 minus x. 70 minus x. So because we have x already as 10, so this will be 50 plus 10, which will be 60 meters. And then for the width, we have 70 minus 10, x is 10, this will give 60 meters. So therefore, the maximum possible area will be 60 meters by 60 meters, because that is a rectangle, and this gives 3600 meters squared. And that is simply how you're supposed to solve that question.